Hello, welcome to Maths Marathon classes. This time 2024 JEE Main limits PYQs, both January and April shift I'll be covering. Totally there are 19 questions. Okay, 2024 we are doing this time. Before this I had done the synopsis part of limits, then 2019 JEE Main questions, 2020, 2021, 2022, 2023, all the JEE Main questions which has appeared in the exam has been solved completely. Also synopsis as I've done with examples, detailed synopsis of limits chapter. And those who are viewing our channel for the first time, for new viewers, just I'll explain to you about our channel. These are the videos. This is Abhiram's Maths Marathon classes. We started recently. 2023 JEE Main PYQs, 2022, 2021, 2020, 2019. Okay, limits, synopsis. Okay, maths formula also I've done. Basic formulas like algebraic identities, differentiation, integration, and trigonometric formulas. Just explained. Inverse trigonometry functions also are done, NCERT level questions, okay, along with concepts. And also recently KCET 2025 mathematics paper I have completely solved. Okay, these are the various videos we have uploaded so far. I'm a new YouTuber actually. You have to support me. I'll be uploading more and more videos, okay, in the coming days. And also you can see these description about our channel, and also you can join these WhatsApp group, Instagram, and also Telegram channel and WhatsApp channel. There are a lot of advantages. I'll be sending the PDF format solutions to all the problems I'll be solving. I'll be solving the problems now, and along with these videos, PDF format also you'll get the solutions, and video solutions are also available for each question. That's the advantage if you join these groups. And at some stage we'll be doing the live classes also, so you will not get any updates if you are not joined to our group or not subscribing to our channel. Okay, so you will not get much information. I'll be doing many more videos in the coming days, not only about JEE, I'll do even CET level questions also, NDA, and even JEE Arc also I'll cover, and various other competitive exams like BIDSAT, MAHE, IISCR, and even many other competitive exams, even NDA also I'll do. Okay, National Defense Academy or Naval Academy, all the PYQs chapter wise I'll do of all the different competitive exams about mathematics I'm telling. Okay, so we'll start the topic of limits now one by one. Okay, take the first question. Given the flower bracket x, the flower bracket x denote the fractional part of x, and f of x given like this: cos inverse of 1 minus fractional part of x square multiplied by sin inverse of 1 minus fractional part of x divided by fractional part of x minus fractional part of x cube. L and R respectively denotes the left hand limit and right hand limit of f of x at x equal to 0. Want to find 32 by pi square into L square plus R square. Question asked on 1st of February, first shift 2024 JEE Main. So we'll find out the left hand limit and right hand limit for this function. Left hand limit at x equal to 0. Right hand limit also at x equal to 0. Then I have to substitute. It's a numerical type question. Options are not given. 32 by pi square into L square plus R square I have to find out. Okay. You must be knowing something about the fractional part of x. Fractional part of x is basically it is x minus greatest integer function. That you must know first of all. Okay. The fractional part function. Fractional part function is defined as x minus greatest integer function. Must know this. The fractional part of x is x minus greatest integer function. Basic idea about the fractional part function. And fractional part of 0.1 is 0.1. Fractional part of any integer is going to be 0. I'll give examples if you want. Fractional part of 0.2 is equal to 0.2. Fractional part of say 5 5 is an integer. There is no fraction present there. fractional part of I is going to be equal to 0. Fractional part of, suppose you want 1.7, it is equal to 0.7. Okay, fractional part of say minus 1.2. If you want to find fractional part of minus 1.2, many students will give the answer as minus 0.2, or they'll give answer as 0.8 or minus 0.8. That's wrong. Answer is 0.8. Answer is 0.8. How to get 0.8? Fractional part of minus 1.2, if you want, minus 1.2 minus integral value of minus 1.2 you should do. Okay, minus 1.2 minus integral value of minus 1.2, that is equal to minus 1.2 minus integral value of minus 1.2 is minus 2, minus of minus 2 plus 2, 2 minus 1.2, that is 0.8. That is how you find the fractional part. And also you must know the fractional part of x always lies between 0 and 1, including 0 excluding 1. The range of the fractional part x is closed open interval 0 to 1. All those things you must know. Okay, I'll be discussing in detail in the functions chapter about the properties of the greatest integer function and the fraction part function. For timing, just understand this much. And fraction part of 0.1 is 0.1. Fraction part of minus 0.1 is 0.9. Correct? So important observation, important thing to be noted is fractional part of 0.1 is 0.1. And if you want fractional part of minus 0.1, it is not 0.1 or minus 0.1, it is going to be 0.9. Okay, and for that, so fractional part of h, where h is a small positive quantity, in that case it is h. And if it is fractional part of minus h, where h is a small positive quantity, very close to 0, h is a number very close to 0 and is positive, in that case fractional part of minus h is 1 minus h. You must know this. These two things are very much required in working out the problems. All these story is not much important, I just told you, but these two things are more important in this problem. Fractional part of h is h. What is h? H is a small positive quantity very close to 0. Fraction part of 0.1 is 0.1. Fraction part of 0.2 is 0.2, like that. Fraction part of minus 0.2 will be 0.8. Fraction part of minus 0.2 is 0.8. How to get 0.8? 1 minus 0.2. Understood? So these two things are important in working out this problem. Okay, all these things not required. Okay, so I'll find out the left hand limit first, then go to right hand limit. I'll be using this idea, okay, in finding the left hand limit and right hand limit. So first we'll find out the left hand limit, L. Left hand limit is limit x tends to 0 minus cos inverse of what we have, 1 minus fractional part of x square into sine inverse of 1 minus fractional part of x divided by fractional part of x minus fractional part of x cube. This much I had to find out the left hand limit for this. X tends to 0 minus means what? The value of x is slightly less than 0. So I'll put x equal to 0 minus h, where x is a small positive quantity close to 0. Okay, this technique already we done many times. Put x equal to 0 minus h, where h tends to 0. 0 means 0 plus a small positive quantity very close to 0. Okay, wherever there is x you put minus h. Wherever there is x you put 0 minus h, which is minus h, where h is a small positive quantity very close to 0, say 0.1 or 0.0 and such a value. So wherever there is x you put minus h. What do you get? Limit h tends to 0, limit h tends to 0, cos inverse of 1 minus fractional part of minus h square into sine inverse of 1 minus fractional part of minus h divided by fractional part of minus h minus fractional part of minus h cube. As I told you, h tends to 0, fractional part of minus h is 1 minus h. I give an example also here. Fractional part of minus 0.1. Fractional part of minus 0.1 is 0.9. How do you get? How to evaluate the fractional part of minus h? That is what I given here. Fraction part of minus h is 1 minus h. Take an example here, already given. Fraction part of minus 0.1 is not 0.1. It's not minus 0.1. It is 0.9. Okay, you can use this definition and get the answer. if you want to find the fraction part of minus 0.1. So I'll be using now fraction part of minus h as 1 minus h. Is that clear? If you want, you can apply this definition to get the fractional part of minus 0.1. Fraction part of minus 0.1 is minus 0.1 minus integral value of minus 0.1. Integral value of minus 0.1 is minus 1. So minus 0.1 minus of minus 1. Minus of minus 1 plus 1. 1 minus 0.1, that is 0.9. So wherever there is fractional part of minus h, I'll put 1 minus h. Is that clear? And evaluate it. I have to find the left hand limit and right hand limit. So this becomes what? I'll write here the remaining part. That's equal to limit h tends to 0 cos inverse of 1 minus fractional part of minus h, I'll write 1 minus h, correct? Many questions are asked in this session, April and January. Totally we have 19 questions altogether. Okay, one by one we'll do slowly. So fraction part of minus h, I'll write 1 minus h the whole square multiplied by sine inverse of 1 minus h divided by what we have. Fraction part of minus h is 1 minus h minus fraction part of minus h is 1 minus h the whole cube. 1 minus 1 is 0, minus of minus h plus h, and simplify this, what we get? Limit h tends to 0 cos inverse of 1 minus, what is 1 minus h the whole square expanded, 1 plus h square minus 2h, open the bracket there, 1 minus 1 becomes 0, minus of minus plus, so plus 2h minus h square, I get here 1 minus 1 is 0, sine inverse of h. Here I can take common in the denominator, 1 minus h is common, so what remains is 1 minus of 1 minus h the whole square, correct? And this is equal to limit h tends to 0, what we have further, cos inverse of 1 minus 1 0, so I'll get 2h minus h square, 2h minus h square, correct, into sine inverse of h divided by 1 minus h into 1 minus 1 0, correct, open the bracket, this will be 1 plus h square minus 2h as I expanded earlier, 1 minus 1 0, so I'll get 2h minus h square, correct, after simplifying and opening the bracket like this I'll get, and I can take h common there, correct. I'll add a page here, okay, otherwise I can write here itself, it's possible. Okay, I'll write down solution here, I can write. Remaining part I'll write here. That's equal to what we have, limit h tends to 0, limit h tends to 0, cos inverse of 2h minus h square. For this we can apply limit actually, 2 into 0 0, 0 minus 0 0, cos inverse 0 is pi by 2, I can apply limit for that. Okay, I'll apply the next step if you want, otherwise cos inverse of 2h minus h square divided by what we have 1 minus h. Here I can take h common, so that will be 1 minus h into 2 minus h, correct, into h, and I can write the remaining what is left out is sine inverse h by h, correct. Here I took h common, h if you take common, what remains is 2 minus h. I wrote 2 minus h here and h here, and for this you can apply limit directly, and you know h tends to 0, sine inverse h by h is 1, this will tend to 1. And this you can apply limit directly, no harm. Denominator is 1 minus 0 into 2 minus 0, correct? Sin inverse h by h is 1 as h tends to 0, already approved also. You know, limit theta tends to 0, sin theta by theta is 1. Same way, limit h tends to 0, sin inverse h by h is also 1. Okay, already approved in the synopsis part. And for this you put h equal to 0, 2 into 0, 0, 0 square 0, 0 minus 0 is 0, cos inverse 0 is pi by 2. So what I'm getting is pi by 2 by 2, that is equal to pi by 4. So left hand limit is pi by 4 I got. Left hand limit is pi by 4. Hope I understood this. Fractional part of x, how to evaluate, you must know. A left hand limit means put x equal to 0 minus h. X tends to 0 minus means slightly less than 0. So put x equal to 0 minus h, where h is a small positive quantity very close to 0. So h tends to 0, and using fractional part of minus h is 1 minus h. Now I'll find out the right hand limit. To find out the right hand limit, I'll take limit x tends to 0 plus. Limit x tends to 0 plus means the value of x is slightly greater than 0. Correct? X tends to 0 plus. I'll add a page here for this so that I can work out the problem entirely, the right hand limit part. Okay, that is right hand limit is r is equal to limit x tends to 0 plus, limit x tends to 0 plus, what we have, cos inverse of 1 minus fractional part of x square, correct? Cos inverse of 1 minus fractional part of x square into sin inverse of 1 minus fractional part of x, sin inverse of 1 minus fractional part of x divided by fractional part of x minus fractional part of x cube. Here I am putting x equal to 0 plus h. Put x equal to 0 plus h, where h is tending to 0. Where h is a small positive quantity very close to 0. So limit x tends to 0 plus, that is what we have is limit h tends to 0, put x equal to 0 plus h, cos inverse of 1 minus, here wherever there is x you put h, 0 plus h, that means slightly greater than 0. H is a small positive quantity close to 0. So that is the indication of right hand limit at x equal to 0 plus. So this becomes fractional part of h square into sin inverse of 1 minus fractional part of h, correct, divided by fractional part of h minus fractional part of h cube, like this. And h tends to 0, already told earlier, fractional part of h is h, fractional part of 0.1 is 0.1, right? So fractional part of h is h. There in left hand limit I use fractional part of minus h equal to 1 minus h. Now I am using fractional part of h as h. So hope you understand how to evaluate the fractional part function when h is a number very close to 0 and it is positive. So cos inverse of 1 minus fractional part of h is h becomes h square into sin inverse of 1 minus h divided by fractional part of h is h. Here also h cube. Like this we get, and h minus h cube we can write h into 1 minus h square, and our aim is to remove the indeterminate form. If you apply the limit directly at this stage, no, 1 minus 0 is 1, cos inverse of 1 is 0, numerator is becoming 0, denominator is 0 minus 0 cube, 0, 0 by 0 form. Applying L'Hopital's rule will be very lengthy here. It won't be so easy to evaluate by using L'Hopital's rule. So I have to use the concepts of inverse trigonometric limits. Okay, I can take h common in the denominator and h into 1 minus h square I'll get, and also I'll convert this, I'm getting 0 by 0, correct? So I'm getting this factor as 0, this term is becoming 0. So I'll express cos inverse in terms of sin inverse. We know cos inverse x equal to sin inverse root 1 minus x square, correct? We know this, cos inverse of x is equal to sin inverse of root 1 minus x square. I'll be using this formula. Cos inverse 1 minus h square will be sin inverse of root of 1 minus h square the whole square, expressing cos inverse in terms of sin inverse. Okay, that I'll do. All these things I'm doing it because our main aim is to remove the indeterminate form. Cos inverse is sin inverse of root of 1 minus h square the whole square into sin inverse of 1 minus h divided by h minus h cube. I can write it as h into 1 minus h square, correct? Simplify it further. Here I'm using this formula, cos inverse x equal to sin inverse of root 1 minus x square. That is applicable when x is positive. When x belongs to the interval 0 to 1, closed interval 0 to 1, if x lies there, we can write this formula. So here x is a small positive quantity, so I can apply this formula. Okay, very close to 0 is positive. So now I can simplify this further. Expand this 1 minus h square the whole square. 1 minus h square the whole square is what? Expansion. 1 plus h power 4 minus 2h square. And 1 minus 1 will become 0 there. Correct? So further, I am simplifying it. This is equal to limit h tends to 0. Limit h tends to 0. Sine inverse of, I am writing directly now. 1 minus 1 becomes 0. What is left out is h power 4 minus 2h square. So minus of that, correct? 1 plus h power 4 minus 2h square. If you simplify, I'll get 2h square minus h power 4 into sine inverse of 1 minus h divided by h into 1 minus h square. I can write 1 minus h into 1 plus h. Correct? And further, this I can write h square common there inside the root. Root of h square will be h. H comes out. H square is common. Root of h square is actually mod h. Mod h is h because h is positive. So I'll write here the remaining part, that is equal to limit h tends to 0. Limit h tends to 0. What we have? Sine inverse of root h square is common. Root of h square is mod h. Mod h is h. H into root of 2 minus h square, correct, multiplied by sine inverse of 1 minus h. For this you can apply limit. H equal to 0, if you put 1 minus 0 is 1, sine inverse of 1 is pi by 2. I can write that. No harm in applying limit for this, correct. Divided by h is there, correct, into 1 minus h and 1 plus h. I can apply the limit. Okay, this much is there. Here we know limit h tends to 0, sine inverse h by h is 1, right? Limit h tends to 0, sine inverse of h divided by h is equal to 1. So this angle, this number is tending to 0, correct? Because h is approaching 0, h into root of 2 minus h square is tending to 0. The terms inside this bracket is approaching 0 as h tends to 0. So h tends to 0, sine inverse of h by h is 1. Whatever there here in the numerator, same thing should be there in the denominator. Sine inverse of something by same thing is 1, correct? These two should be same. So inside the bracket, what is there? H into root of 2 minus h square. So I'll multiply and divide by root of 2 minus h square here. Multiply and divide by root of 2 minus h square, and whatever remaining part is there, no, this much. For this I'll apply the limit. For this I'll apply limit. Limit h tends to 0. Limit h tends to 0. What we have? Sine inverse of 1 minus h. Sine inverse of 1 minus h divided by 1 minus h into 1 plus h. For that we can apply the limit directly. There is no harm in applying the limit for that. Okay, and here this part will become 1. Sine inverse of h into root of 2 minus h square by h into root of 2 minus h square is 1 using this formula. So this becomes equal to 1 into, for this also I can apply limit now, root of 2 minus 0 into sine inverse of 1 minus 0, that is pi by 2, divided by 1 minus 0 is 1, 1 plus 0 is also 1, 1 into 1. So what I am getting is root 2 into pi by 2. Correct, denominator is 1. So 2 I can write root 2 into root 2. So 1 root 2 will cancel here. Correct. So answer we get pi by root 2 there. Pi by root 2 I am getting. That is right hand limit. Right hand limit is simplifying to pi by root 2. Hope you understand this. Root 2 into pi by 2 is root 2 into root 2. 1 root 2 cancels. Therefore, I get right hand limit as pi by root 2. The question asked is to find what? Therefore, the required question was to find 32 by pi square into L square plus R square. Correct? 32 by pi square. 32 by pi square into L square plus R square. That is what we want to find. That's equal to 32 by pi square into what is L? L we got the left hand limit pi by 4, correct? Left hand limit we got pi by 4. Pi by 4 square. Right hand limit we got pi by root 2. Pi by root 2 square. Simplify this. what do we get? This is equal to 32 by pi square into, this is pi square divided by 16 plus pi square divided by 2. Simplified further, we'll get the answer. Taking common denominator as 16 there, I can get the answer for this. That's equal to 32 by pi square. 16 is common denominator. 16 into 1, 1 into pi square is pi square. 2 into 8, 8 into pi square, 8 pi square. So it becomes 16 ones are 16 twos are. Correct? That's equal to 2 by pi square into what we have, 9 pi square. Correct? Pi square is going to cancel. 2 into 9 is 18. Required answer is 18. Quite lengthy question this is. Required answer is 18. Hope you understood how to find left hand limit and right hand limit. The given function involves the fractional part of x. Finding the left hand limit and right hand limit and substituting. L is the left hand limit and R is the right hand limit. Also I can show you the solution for this. Solution is quite lengthy. I have given the detailed solution here. It will be sent in the PDF format, and for each question there is video solution also will be uploaded in the YouTube and also in our WhatsApp channel. Okay, please subscribe to my channel if you're not subscribed. Okay, lot of benefits are there if you subscribe to my channel. I'll be doing the live classes also in coming days. This is a solution given to you, which is typed already. Detailed solution is given, the left hand limit and right hand limit. If you want, you can take a screenshot as well. Move on to the next one. Question number 2. F of x given as, first case, x minus 1 if x is even. Second case, the given 2x if x is odd. X minus 1, x is even. 2x, x is odd. X belongs to natural number. If for some a belongs to natural number, f of a equal 21. Find limit extends to a minus of mod x cube divided by a minus greatest integer value of x by a. The various options are given. Question was asked on 1st of February, 2nd shift 2024 JEE Main. So this is a mixing type of concept. Mixing question is there. Actually, the concept is mixed here. Not only limits concept, also you must know about the composite function. F of a is there. And there are two cases given, odd and even. Two cases are given. So I'll discuss separately two cases. For x is even number, f of x defined as x minus 1. For x is odd number, f of x is defined as 2x. So I'll discuss two cases. If x is even and x is odd, separately we'll discuss. Okay. Case 1 will take x is even. Case 1, x is even. If x is even. If x is even, f of a equal to 21. You solve that equation. You solve this equation and get the value of a. That a you can substitute and get the answer. Limiting value is easy. Finding limit of this expression is easy. Even this is also easy, but little more work is there. Okay. So I'll solve this equation now. F of a is equal to 21. Instead of x, I'll take a. A is even. I'll take. Okay, not x is even. I'll take a is even. Take a is even because f of a is there, no? If a is even. If a is even, f of a is equal to 21. Solve this equation, get the value of a. Okay, then you can substitute. So to solve this, f of what is f of a? A is even number. For even number, f of x defined as x minus 1. Instead of x, a. So f of a is a minus 1. Correct? If x is even, f of x is x minus 1. If a is even, f of a is a minus 1. This becomes a minus 1 is equal to 21. If a is even, a minus 1 is odd number. Any even number minus 1 is odd number. Suppose you take 8. 8 is even number. 8 minus 1 is 7. 7 is odd number. So a minus 1 is odd number, right? A minus 1 is odd number. For odd number, the function is defined as 2x. So a minus 1 is odd number. F of a minus 1 is 2 times a minus 1. Because if x is odd, f of x defined as 2x. 2 2 times whatever there inside the bracket for odd number. Because a minus 1 is odd number, f of a minus 1 becomes 2 times a minus 1. Hope you understand. I'm using the second line here. That becomes f of, what is f of a minus 1 now? 2 times a minus 1. Correct? And 2 times a minus 1 is always 2 into something, 2 into some natural number, or is a 2 into some number is always even, right? 2n is even number. So 2 times a minus 1. A minus 1 is odd or even. 2 times a minus 1 is always even. I can give guarantee. Correct? So 2 times a minus 1 is even number. For x is even, f of x defined as x minus 1. So 2 times a minus 1 is even. So f of 2 times a minus 1 is 2 times a minus 1 minus 1. Understood? If x is even, f of x is x minus 1. Right? Now 2 times a minus 1, 2 times a minus 1 is even. Correct? So f of 2 times a minus 1 is going to be 2 times a minus 1 minus 1. First line I am applying. So 2 times a minus 1 minus 1 is equal to 21. If we solve this, 2 times a minus 1 is equal to 21 plus 1, 22. That means a minus 1 is equal to 11. 2 ones are 2 11s. That means a is equal to 12. For a is equal to 12, you find out the limiting value. Put a is equal to 12. What do you get? Limit x tends to 12 minus. Putting a as 12. What we have? Mod x cube divided by a minus greatest integer value of x by a is how much? A is 12. No, a can substitute. A is 12 I got. A is 12. I can substitute the value. A is 12, correct? Integral value of x by 12. X tends to 12 minus. 12 minus means what? It's an indication of left hand limit. The value of x is slightly less than 12. So 11.9 you can take, or 11.99 you can take. 11.99 is a positive value, right? So first, whenever there is modulus function and greatest integer function, you have to evaluate that function at the given point. X is approaching 12 from the left side, slightly less than 12. Slightly less than 12 is 11.99. 11.99 is a positive number. So mod x is x because x is positive. So I'll evaluate the modulus and greatest integer function at 12 minus. Okay. Mod x is going to become x because x is positive. 12 minus means it's a positive value. So mod x is x cube divided by 12 minus integral value of x by 12. X is slightly less than 12. So 11.99. 11.99 divided by 12 is a number which is less than 1. So greatest integer value of a number, say 0.99, it is going to be equal to 0. Correct? 12 minus means slightly less than 12, say 11.99. 11.99 divided by 12 will be 0.9 something, 999. We're very close to 1 but less than 1. I can tell this x by 12 is less than 1, greater than 0, less than 1 for x tends to 12 minus. So integral value of 0 point something, 0.999 is going to be 0. Now we can apply limit for this. X almost becomes equal to 12. 12 cube divided by 12, which is 12 square, which is equal to 144. We got the answer by discussing case 1. 144 is the answer. If you go for second case, I discussed so far only the first case where a is even. I'll take the second case where a is odd number. Okay. If a is odd number, what happens? If a is odd number, second case, I'll write here itself. Case 2. If a is odd number, a is odd. If a is odd, I'll solve this equation. F of a equal to 21. F of a is equal to 21. What is that? F of a is odd number. For odd number, if x is odd number, f of x is 2x. If a is odd number, f of a will be 2a. Correct? Is equal to f of, what is f of 2a? 2a is even, right? If 2 into something is always even, as I told you. Even number is represented by 2n and odd number is represented by 2n plus 1 or 2n minus 1. So 2a is going to be even number, multiple of 2, correct? 2a represents multiple of 2, it's even number. So for even number, if x is even, f of x is x minus 1. So now 2a is even number, f of 2a will be 2a minus 1, correct? F of x, x minus 1 for x is even. Now 2a is even, so f of 2a is 2a minus 1. That is the first line. So 2a minus 1. 2a minus 1 is an odd number, correct? As I told you. 2a minus 1 and 2a plus 1 is always representing an odd number. For a is any integer or a is a natural number in the case. So 2a minus 1 is odd number, correct? So if 2a minus 1 is odd number, for x is odd, f of x is 2x. 2a minus 1 is odd number, f of 2a minus 1 is 2 times 2a minus 1. I'm using the second line. So I'm getting 2 times 2a minus 1 is equal to 21. Or I get 2a minus 1 is equal to 21 by 2. Or I get 2a is equal to 21 by 2 plus 1, that is 23 by 2. I'm getting a is equal to 23 by 4, which is not a odd natural number, correct? This is not possible. This case is not possible because I took a is odd natural number. 23 by 4 is not an odd natural number, correct? It's not possible. This case is not possible. Second case is not possible. Only case 1 is possible where we got the value of a is equal to 12 and I could evaluate the limit and I got the answer as 144. Hope I understand this. We're solving the equation first. F of a equal to 21. Solve this equation, get the value of a using the definition of f of x. There are two cases, the definition of f of x for even number and odd number. Okay, then get the value of a and substitute. Okay, this is our solution. 144 is the answer, option B. Solution is also given to here. Detailed solution is given. If you want, you can take a screenshot. Also, the PDF format of the solution will be sent in the WhatsApp channel. Okay, also will be uploaded in the YouTube. All these things. Subscribe to my channel if you're not subscribed. Lot of benefits are there if you subscribe to my channel, and also give more likes so that I'll get more confidence in working out the problems or teaching all the problems to you. Okay, we are doing 2024 JEE Main now. After this I'll go to 2025 JEE Main. January and April should both I'll be covering. Then after finishing limits I'll go to continuity chapter. Okay, one by one we'll discuss all the synopsis part and PYQs of JEE Main. Move on to the next one. Question number 3. A is equal to limit x tends to 0, square root of 1 plus x power 4 minus root 2 by x power 4. B is equal to limit x tends to 0, sin square x divided by root 2 minus root of 1 plus cos x. Want to find the value of a into b cube. It's a very simple question. If you apply limit directly, this takes 0 by 0 form. Even this will take 0 by 0 form. If you apply the limit directly, x equal to 0, sin 0, 0, 0 square 0. Denominator, cos 0 is 1, 1 plus 1, 2, root 2 minus root 2, 0, 0 by 0 form. You can apply L'Hopital's rule. Even this type of question was asked in 2019 JEE Main. Same, only one was there, only this was there actually, this was not there. And even this is a simple question actually. This question itself is very simple. What is the advantage of working all the PYQs is same type or similar type of questions will be asked. If not exactly the same, similar type of questions, and you'll get a more idea. And if you work out all the PYQs till now, whatever exams are over, all the PYQs, if you work out, definitely you can get good score. I can give guarantee. Because very similar type of questions will be asked in the exam. Okay, first you learn all the formulas and work out the problems. First PYQs. If you have finished PYQs, that is you have finished the level 1, round 1 type of question. Then you can go to higher level questions, still higher level questions. You can also study JEE advanced PYQs, okay? Because many times in JEE Mains also nowadays, in the recent papers, JEE advanced PYQs, similar type questions are asked, okay, in JEE Mains exam. If you see from 2014 onwards, if you see JEE advanced exam, so all PYQs if you study, it's very beneficial, okay, in preparation of JEE Mains, okay. So you can study both JEE Mains as well as JEE advanced. Because it takes 0 by 0 form, for both A and B, I'll apply L'Hopital's rule. Okay, differentiate numerator and denominator separately. A is equal to, apply L'Hopital's rule. Differentiate numerator and denominator separately. Apply L'Hopital's rule. Differentiating numerator and denominator separately. What do you get? A is equal to, limit x tends to 0. Derivative of root x, you must know chain rule here. Derivative of root x is 1 by 2 root x. 1 by 2 root of 1 by 2 root of 1 plus root of 1 plus x power 4 into derivative of terms inside the root. Derivative of 1 is 0. Derivative of root 1 plus x power 4 is 1 by 2 root of 1 plus x power 4 into derivative of 1 plus x power 4 is 4x cube. Derivative of root 2 is 0 divided by derivative of x power 4 is 4x cube. I can cancel this 4x cube here. Correct? Now I can apply limit at this stage. It doesn't take 0 by 0 form. 2 into 2 is 4. Root of 1 plus root of 1 plus 0 into root of 1 plus 0. Correct? Putting x equal to 0. 2 into 2 is 4. 1 plus 0 is 1. Root 1 is 1. 1 plus 1 2. Root 2. Here root 1 is 1. So what I am getting is 1 by 4 root 2. Very simple. 2 lines. I got the answer. A is equal to 1 by 4 root 2. Similarly, apply L'Hopital's rule for B also. B is given as limit x tends to 0. Here also I am applying L'Hopital's rule. B is equal to limit x tends to 0. Derivative of sine square x. Differentiate as you differentiate x square. Derivative of x square is 2x. Derivative of sine square x is 2 sine x into derivative of sine x is cos x. 2 sine x cos x. Correct? Divided by differentiate denominator. Derivative of root 2 is 0. Derivative of root is 1 by 2 root. So 1 by 2 root of 1 plus cos x into derivative of 1 plus cos x is minus sin x. Derivative of 1 plus cos x is minus sin x. Minus into minus will become plus. The sin x will cancel. This 2 root of 1 plus cos x will go up. Limit x tends to 0. Limit x tends to 0. Minus into minus will become plus. This 2 will go to numerator. 2 is already there. 2 into 2 becomes 4 cos x into root of 1 plus cos x. Correct? Taking this to numerator. Now apply the limit directly for this. 4 into cos 0 into root of 1 plus cos 0. Cos 0 is 1. Cos 0 is 1. So what do you get? 4 into 1 into root of 1 plus 1 root 2. 4 root 2. A is 1 by 4 root 2. B is 4 root 2. Want to find A into B cube. Therefore, A into B cube they ask. A into B cube. A how much we got? 1 by 4 root 2. And B is 4 root 2 cube. 4 root 2 cube. 1 4 root 2 will cancel. Correct? 4 root 2 square remains. So 4 root 2 square is 4 square is 16. Root 2 square is 2. 16 into 2. Answer is 32. Answer is option B, 32. Very simple question. For A and B, both we apply L'Hopital's rule. Differentiate numerator and denominator separately. L'Hopital's rule is frequently asked question. Even CET exam also, L'Hopital's rule is the most familiar question. Solution is also given to you. A is here and B is here. A into B cube is 32. Option B is the answer. Move on to the next one. Question number 4. Limit x tends to 0. 3 plus alpha sin x plus beta cos x plus log of 1 minus x divided by 3 tan square x given to be equal to 1 by 3. Find 2 alpha minus beta. There are two unknowns here, alpha and beta. So I should get two equations. And for denominator, multiply and divide by x square. Because tan x by x is 1. I'll make denominator as 3x square. Okay. If you multiply and divide by x square in the denominator, we know limit x tends to 0, tan x by x is 1. So denominator will become 3x square. And for numerator, to find the unknowns alpha and beta, I'll be using series expansion. Series expansion for sin x, series expansion for cos x, infinite series expansion I'm using Maclaurin series formula. A log of 1 minus x is minus of x plus x square by 2 plus x cube by 3 etc. up to infinity. And denominator is x square means you can write only the infinite series expansion up till x square. Afterwards, higher powers will become 0. That's an important point to be noted. It depends upon denominator. If denominator is x square, write the infinite series expansions for sin x, cos x and log 1 minus x up till x square is enough. Higher powers of x not required. Okay. If denominator is x cube, in that case you write the infinite series expansions for whatever functions given, sin, cos and log 1 minus whatever there in the numerator. For all those things you write the series expansion up till x cube. That's an important point to be noted. So first of all, in the denominator, I'll multiply and divide by x square. Okay, limit x tends to 0. Limit x tends to 0. This is a frequently asked question, this type, series expansion type of question. 2019 and 20 they didn't ask any questions on series expansion. 2021 onwards they started asking questions on series expansion. Multiplying and dividing by x square in the denominator. Tan square x by x square is 1 as x tends to 0. Here it is 3 plus alpha sin x plus beta cos x plus log of 1 minus x. I have to use the series expansion for all these things. Denominator is 3 into 1 into x square, 3x square. So what we have? Limit x tends to 0, limit x tends to 0, 3 plus alpha into, write the series expansion for sin x, x minus x cube by 3 factorial, etc. up to infinity, plus beta into cos x is what? 1 minus x square by 2 factorial plus x power 4 by 4 factorial, etc. up to infinity. That's not required. Log 1 minus x is minus of x plus x square by 2 plus x cube by 3, etc. up to infinity. Whole thing is divided by 3x square. Correct? Denominator is 3x square is equal to 1 by 3. Now we can group the terms. Write the terms without x, that is constant terms. Here there is no constant term in this bracket. Here beta into 1, that is a constant term. Here there is no constant term. So 3 plus beta in one bracket. Also you separate the terms simultaneously. So I can say the steps and I can say the time also. 3 plus beta. All these things you should do the mind calculations. You can't write many steps in the exam. Time save, you should save your time. Okay. Constant terms I am writing. Constant term is without containing x. Terms without x. 3 plus beta by 3x square. Plus here you take x common. X is present from this bracket and this bracket. Here there is no term with x. So x if we take common here, what remains is alpha, coefficient of x alpha. Here coefficient of x is minus 1 there. Correct? Separated, divided by 3x square. Next, if you want, you collect the terms with x square. Here there is no x square. Here there is x square. Here there is x square. If you take x square out, if you take 2 factorial is 2. So minus beta by 2. Minus beta by 2. Here coefficient of x square is minus half. Correct? Divided by 3x square. Plus other terms. As I explained in many problems. Next term x cube into something divided by 3x square. X cube by 3x square will be x into something, correct? So x term, x is approaching 0. From here onwards all the terms are becoming 0. So I am not writing that. Is equal to 1 by 3. Correct? Higher terms, higher powers of x not required. The important technique is if denominator is x square, write the terms up till x square. X cube onwards it becomes 0 because x cube by x square is x. Correct? That limit, if you apply limit for that, x is becoming 0. Next term will be x power 4 by x square. X power 4 by x square is x square. X square is becoming 0. 0 into something 0. Like that it becomes 0 all the terms. Now for limit x tends to 0, denominator is becoming 0. That means 3 plus beta by 0 means limit does not exist. But limiting value is already given to be equal to 1 by 3. That means limit of this function is going to exist finitely. For limit to exist finitely, what we should have 3 plus beta should be 0. Means is the condition that 3 plus beta is equal to 0. Same story here also. 1x will cancel, denominator will become 3x. As x approaches to 0, denominator is becoming 0. Denominator 0 means numerator should become 0. So that becomes limit exists finitely. Alpha minus 1 should be 0. From this I get beta is equal to minus 3 and alpha equal to 1. Correct? And this is not required because there are only two unknowns, alpha and beta, two equations enough to get the answer. So therefore, finally we wanted to find 2 alpha minus beta. 2 into alpha how much? 1. Beta how much? Minus 3. 2 plus 3 that is equal to 5. 2 minus minus 3. 2 plus 3 is 5. Option C is the answer. Question based on infinite series expansion. Solution is also given to you. Answer is 5. Option C is the answer. Detailed solution is given to you. Move on to the next one. Question number 5. Limit x tends to pi by 2 is there. Integration is there. That means it's a combination of L'Hopital's rule and Newton-Leibniz formula. So many times we have done this type of problem. So that's the advantage of working out PYQs. Similar type of questions will be there. Not exactly same, I can tell you, but definitely similar type questions will be asked. But you need to practice. If you're writing the exam in the January shift, not you start preparing the month of December. Now itself you have to start. Okay. By this time you should have finished all the syllabus of NCERT, first PU and second PU. Now it's the time to start studying JEE. We are at the May 27th, or we are at the end of May, correct? So you should be able to start studying now itself. June, July, August, September, October, November, December, so many times is there, correct? So you have to start studying all these things now itself. The question asked on 29th of January 1st, 2024. If you apply limit directly, see denominator is becoming 0. X tends to pi by 2. Pi by 2 minus pi by 2 is 0. This is denominator. Numerator is here, correct? X cube. X is approaching pi by 2. Pi by 2 cube. Lower limit is pi by 2 cube. Upper limit also pi by 2 cube. Lower limit and upper limit is same, means the value of the definite integral is going to be 0. So 0 by 0 form. It takes 0 by 0 form. So I can apply L'Hopital's rule. I can apply it takes 0 by 0 form. Hence you can apply L'Hopital's rule. Apply L'Hopital's rule. Differentiate numerator and denominator separately. Okay, that is equal to what I'll write. Limit x tends to pi by 2. Limit x tends to pi by 2. D by dx of integral from x cube to pi by 2 cube. Pi by 2 cube. Cos of t power 1 by 3 dt divided by d by dx of x minus pi by 2 the whole square. I'm differentiating the numerator and denominator separately. For numerator, I apply Newton-Leibniz formula. Integration and differentiation is going to cancel out. Substitute the upper limit into derivative of upper limit, minus substitute the lower limit into derivative of lower limit. Okay, that's equal to limit x tends to pi by 2. Applying Newton-Leibniz formula in the numerator, what happens? Cos of, put t equal to pi by 2 cube. Pi by 2 cube power 1 by 3 is pi by 2. So it becomes cos pi by 2 into derivative of pi by 2 derivative of constant is 0. Substitute the upper limit in place of t. For integration the variable is t. For t you put the upper limit into differentiate the upper limit, minus. Now substitute the lower limit in place of t, put the lower limit. What is lower limit? X cube. X cube power 1 by 3 is x. Cos x into derivative of x cube is 3x square, correct? Divided by denominator, derivative of x minus pi by 2 the whole square is 2 times x minus pi by 2 into derivative of x minus pi by 2 is 1, correct? Like this we get. This part is becoming 0. And now what is left out? Now for that again if I apply the limit, still it is taking 0 by 0 form. See, cos pi by 2 is 0. 0 into something 0 here. Pi by 2 minus pi by 2 is 0. Again apply L'Hopital's rule. Okay, what we getting here? This part is 0, correct? This 2 we can keep outside. 3 also you can keep outside. Minus 3 by 2 keep outside. It's a constant. Minus 3 by 2. Minus 3 by 2. This is becoming 0. Cos pi by 2 is 0. 0 into 0 is 0. This I am not writing. This part here the constant term is minus 3 by 2. What is left out here? Limit x tends to pi by 2. Limit x tends to pi by 2. What is that? X square into cos x divided by what we have? X minus pi by 2. X minus pi by 2. Or you can apply L'Hopital's rule here, or else I can write cos x as sine of pi by 2 minus x using allied angles, concept of allied angle. That is better, I think. That's equal to minus 3 by 2. Otherwise I have to apply product rule. No, it becomes little bit lengthy. I can avoid that. X square into sine x you write, cos x you write, sine of pi by 2 minus x, correct? Sine of pi by 2 minus x. Here you can take one minus sign out. Minus of pi by 2 minus x second, right? As x approaches pi by 2 minus x is tending to 0. This angle is tending to 0. Sine of an angle by same angle is 1, right? As theta tends to 0, sine theta by theta is 1. Sine of an angle by same angle is 1. This part is becoming 1. This part is approaching 1. So what is left out? This minus and this minus will multiply and becomes plus 3 by 2. And what is rounded off is 1. For this you put x equal to pi by 2 square. x is approaching pi by 2 into 1, correct? So what do you get? 3 by 2 into pi square divided by 4. So answer is 3 pi square divided by 8. For second time, instead of applying L'Hopital's rule, I am using trigonometric limit. Sin theta by theta is 1 as theta tends to 0. Because as x approaches to pi by 2 minus x, this angle is tending to 0. This angle is tending to 0. This angle and this angle same. Exactly in the form of sin theta by theta equal to 1 as theta tends to 0. Hope you understand. What is rounded off is 1. In the denominator x minus pi by 2, I wrote it as minus of pi by 2 minus x. This minus into this minus will become plus. Correct? 3 by 2. What is rounded off is 1. And for this, you apply limit x equal to pi by 2 square. Pi square by 4 into 3 by 2. 3 pi square by 8. Option C is the answer. I think in the solution, I used L'Hopital's rule again for the second time. But you can avoid L'Hopital's rule for second time. Using trigonometric limits, you can evaluate easily. Answer is option C. 3 pi square by 8. I think I use L'Hopital's rule here. You can avoid. Instead of L'Hopital's rule, you can use cos x as sine of pi by 2 minus x, and denominator x minus pi by 2 is minus of pi by 2 minus x. So that you get the answer as option C. If you want, you can take a screenshot of this. Move on to the next one. Question number 6. Slope of the line is given. Oh, straight lines concept is mixed with limits here. Slope of the straight line. Ax plus by plus c equal to 0 is minus a by b. Or if equation of a line is given, slope how to find? Minus coefficient of x by coefficient of y. Slope of this line is minus 45 by 5 minus 9. That is given to be equal to 27 r1 plus 9 r2 by 2. Slope is given minus 45 by 5. Slope of the line, slope is minus coefficient of x by coefficient of y. This is a concept in straight lines actually. If you are aware of straight lines, you can do it. Slope is given to be equal to minus, or equation of the line is given. From there I can write minus coefficient of x is 45 and coefficient of y is 5. Minus 45 by 5. That simplifies to minus 9. Slope is given to be equal to 27 r1 plus 9 r2 divided by 2. Okay, this I'll use this. I'll be using this. Slope is given to be equal to 27 r1 plus 9 r2 by 2. r1, r2 are real numbers. You want to find limit x tends to 3 of this. Integration sign is there. So if you apply limit directly, it becomes 3 to 3. 3 to 3 means integration sign is 0. Integration is only for the numerator because variable is t. dt is there means the variable of integral is t. Denominator you can separate. I can write this expression as limit x tends to 3. Limit x tends to 3. Correct? What we have? Integral from 3 to x 8t square dt. 8t square dt divided by what we have? 3 r2x divided by 2 minus r2x square, correct, minus r1x cube minus 3x, like this. Integration is only for numerator. If you apply limit directly, upper limit becomes 3 here, correct? X is approaching 3, 3 to 3. Integral from 3 to 3 of any function is 0 because integration value is 0 if lower limit and upper limit is same. So numerator is 0. Denominator also becomes 0 if you apply limit directly. 3 into 3 is 9, correct? Here 3 r2 into 3 becomes 9 r2 by 2, correct? If you apply limit directly for the denominator, that also becomes 0. That is by using this equation. Using this equation, I have to use this equation because I'll get expression in terms of r1 and r2. I'll get in terms of r1 and r2. If you want to show this denominator, numerator becomes 0 in already. Denominator, see, put x equal to 3. What do you get? If you put x equal to 3, 3 into 3, 9. 9 r2 by 2 I'll get. 9 r2 by 2 minus r2 into 3 square 9. So minus 9 r2 minus 9 r2. Correct? 3 cube is 27. So minus 27 r1 minus 27 r1 minus 3 into 3 minus 9. And 9 r2 by 2 minus 9 r2 will be minus 9 r2 by 2. Correct? Minus 27R1 minus 9. And this expression, see 27R1 plus 9R2 by 2, correct? If you take minus sign out from this, if you multiply this by minus 1, I'll get minus 27R1 minus 9R2 by 2, which comes to 9. This part will become 9, correct? According to this equation, this much will become 9. So 9 minus 9 is 0. So denominator is becoming 0. Numerator becomes 0, denominator becomes 0 as x is approaching to 3. So it takes 0 by 0 form, correct? It takes 0 by 0 form. So I can apply L'Hopital's rule. Differentiate numerator and denominator separately. Apply L'Hopital's rule. Apply L'Hopital's rule. Differentiate numerator and denominator separately. Apply L'Hopital's rule. Differentiate the numerator and differentiate the denominator separately. What we get? That is equal to limit x tends to 3 d by dx of integral from 3 to x. What we have? 8t square dt. Differentiate the denominator as well. d by dx of, what do you get? 3r2x by 2 minus r2x square minus r1x cube, correct? Minus 3x. Here integration and d by dx will cancel out. What you get is, substitute the upper limit x, 8x square into derivative of x1, 8 into 3 square, and derivative of 3 is 0, correct? Denominator differentiate 3r2 divided by 2 minus 2r2x, correct? Minus 3r1x square minus derivative of 3x is 3, correct? Now you can substitute the value of x. X is approaching 3. You can substitute the value of x. It doesn't become 0 by 0. 3 square is 9. 9 into 8 is 72. 8 into 9, correct? 3r2 by 2. 3r2 divided by 2. Putting x equal to 3. 3 into 2, 6. 6r2. 3 square is 9. 9 into 3 is 27. This becomes 27r1 27r1 minus 3, like this I'm getting, correct? And you can simplify the like terms here. 3r2 by 2 minus 6r2 by 2. 6 is 12 by 2. So 3 by 2 minus 12 by 2 is minus 9 by 2. So minus 9r2 by 2 minus 27r1. I'll get the remaining part, I'll write here. Okay. The remaining part, you can write it here. That's equal to, numerator is 72, denominator is how much? 3r2 by 2 minus 6r2, 3 by 2 minus 6, minus 9 by 2, correct? Minus 9 by 2 minus 9r2 by 2 minus 27r1 minus 3, like this I'm getting. And this part I can use this equation. What is 9r2 by 2 plus 27r1 minus 9? If you multiply this by minus 1, I'll get this expression, correct? This much I'll get. Minus 9r2 by 2 minus 27r1 will be plus 9. So what I'm getting is 72 divided by, this bracket is 9 minus 3. So I'm getting 72 divided by 6, that is equal to 12. Required answer is 12. Numerical type question asked on 29th January, second shift, 2024 JEE Main exam. Slope concept is used. Slope is minus coefficient of x by coefficient of y. Equate it to this and keep it aside. I'll be using it later. Take 0 by 0 form. If I apply limit directly, integral from 3 to 3, it becomes 0. And using this equation, this denominator is becoming 0. And apply L'Hopital's rule. For numerator, apply Newton-Leibniz formula. Substitute the upper limit, differentiate the upper limit. Minus, substitute the lower limit, differentiate the lower limit. Denominator also differentiate and apply the limit, get the answer. Answer is 12. Solution is also given to you. The detailed solution is given. If you want, you can take a screenshot for all these things. Move on to the next one. Question number 7. A function f is defined from closed interval minus pi by 2 comma pi by 2 to r differentiable function such that f of 0 is half and limit x tends to 0 x into integral from 0 to x f of t dt by e power x square minus 1 is given to be equal to alpha. Find 8 alpha square. Question asked on 30th of January 1st shift 2024. Again, limit is there, integration sign is there, two things, L'Hopital's rule and Newton-Leibniz, combination of both, correct? Limit x tends to 0, x into integral from 0 to x f of t dt, correct, divided by e power x square minus 1 is given to be equal to alpha. We know the familiar theorem on exponential function that limit x tends to 0 e power x minus 1 by x is 1. The power and the denominator should be same and both should approach to 0. Here the power is x square. As x approaches to 0, x square also approaches to 0. Correct? You divide by x square and multiply by x square. This will approach to 1. Correct? As x approaches to 0, even x square approaches to 0. E power x square minus 1 by x square is 1. Denominator, this bracket is 1 using this theorem. Using this. Correct? Instead of x, we have x square. And 1x is going to cancel here. This x square. 1x will cancel. So 1x remains here. So numerator only integral sign is there. Limit x tends to 0. What we have? Integral from 0 to x f of t dt divided by what we have, this part is 1, this bracket is 1, only x is left out, is equal to alpha. If you apply limit directly, integral from 0 to 0, lower limit is 0, upper limit is 0, integration value will be 0, denominator is 0, takes 0 by 0 form, correct? Takes 0 by 0 form. So you can apply L'Hopital's rule. Differentiate numerator and denominator separately. Apply L'Hopital's rule. Apply L'Hopital's rule. Differentiate the numerator and denominator separately. What do you get? Limit x tends to 0. Limit x tends to 0. D by dx of integral from 0 to x f of t dt. Correct? Divided by d by dx of denominator. Differentiate the denominator is given to be equal to alpha. Integration and d by dx is cancelling. The upper limit, differentiate the upper limit. Limit x tends to 0. What we get? F of x into derivative of x1 minus f of 0 into derivative of 0, 0 divided by derivative of x is 1 is equal to alpha. This part is 0. So apply limit x equal to 0, f of 0. Correct? X equal to 0. As x approaches, this is 0. F of 0 to 0, 0. I'm getting f of 0 equal to alpha. F of 0 given in the question as half using this. F of 0 equal to half. I'm getting alpha is equal to half. Alpha is half. What they ask to find is 8 alpha square. Therefore, 8 alpha square is required. I'll write here remaining part. 8 alpha square is required. 8 into alpha, how much we got? 1 by 2. 1 by 2 square is 1 by 4. 8 into 1 by 4. Answer is 2. Option B is the answer. Here multiply and divide by x and the denominator and use this limit theorem, limit of exponential function e power x minus 1 by x is 1 as x tends to 0. Instead of x we have x square here. So denominator this part is 1. 1 into x square is x square. 1x will cancel. So we can apply L'Hopital's rule because it takes 0 by 0 form. For numerator apply Newton-Leibniz formula. Integration and d by dx will cancel out. Substitute the upper limit. Differentiate the upper limit. In place of t put the upper limit. What is upper limit? X. So f of x into derivative of x1 minus in place of t put the lower limit. Lower limit is 0. So f of 0 into derivative of 0. Derivative of 0 is 0. So this part is 0. 0 into f of 0, 0. F of x left. Apply limit f of 0 equal to alpha. F of 0 is given to be equal to half. So alpha is equal to half. Finally, we want to find 8 alpha square. Find out. Required answer is 8 into 1 by 4, which is 2. Option B is the answer. Solution is also given to you. Hope you understand this. Next one, question number 8. A be the sum of all coefficients in the expansion of this. B is given as limit extends to 0 of this. And if the equations cx square plus dx plus e equal to 0 and 2bx square plus ax plus 4 equal to 0 have a common root, c, d, e are real numbers. Find d is to c is to e. How much? Question asked on 31st of January 1st shift 2024. So sum of the coefficients is a concept of binomial theorem and limit is there, and also we got the concept of quadratic equation. It's a mixture of many concepts here. Binomial theorem is involved, limit is involved, and also the quadratic equation is involved. Okay, so I have to find out how to find sum of all coefficients. Sum of all coefficients is got by putting x equal to 1. You must know this. Okay, so a is equal to just put x equal to 1 in this expression. Put x equal to 1. 1 minus 2 plus 2 to the power 2023 multiplied by 3 minus 4 into 1 square plus 2 into 1 cube to the power 2024. Minus 2 plus 2 cancels. 1 to the point number is 1. Correct? Here 3 plus 2 is 5. 5 minus 4 is 1. 1 to the power 2024 is 1. So A is 1. A is 1. How to get sum of the coefficients? Sum of the coefficients is got by putting x equal to 1. So sum of the coefficients we got a equal to 1. B you find out. Again limit is there, integration sign is there, combination of L'Hopital's rule and Newton-Leibniz formula. So B can write it as B is equal to, I'll separate and write limit x tends to 0. B is given as limit x tends to 0. Integral from 0 to x. 0 to x log of 1 plus t log of 1 plus t divided by t power 2024 plus 1 whole thing is divided by x square. If I apply limit directly, integral from 0 to 0. 0 to 0 is 0. Integration sign becomes 0. Here 0 square is 0. Take 0 by 0 form. Apply L'Hopital's rule. Differentiate numerator and denominator separately. This will take 0 by 0 form. So differentiate the numerator and denominator separately. I'll write here itself. Differentiate this d by dx of. D by dx of. Differentiate the numerator and denominator separately. Your integration and d by dx will cancel. Substitute the upper limit, differentiate the upper limit. Substitute the lower limit, differentiate the lower limit. Becomes lower limit is 0. Correct? So b is equal to what? Integration and d by dx will cancel out. What you get is log of 1 plus x, correct, divided by x power 2024 plus 1 and into derivative of x1, lower limit is 0, so integral lower limit is 0 only. If you want to show into derivative of x1 minus substitute the lower limit log of 1 plus 0 by 0 power 2024 plus 1 into 0. Something whatever I get here expression into 0 will be 0 because derivative of 0 is 0. Denominator to differentiate derivative of x square is 2x. Of course limit is there here. Limit x tends to 0 is there. Don't forget that. Only integration and d by dx got cancelled. So what is left out now? B is equal to limit x tends to 0. I can rewrite this as log of 1 plus x divided by 2x, correct, this by this into 1 by x power 2024 plus 1, correct. Log 1 plus x by x is 1 as x tends to 0. We know this. So 1 by 2 into here 1 by putting x equal to 0, 0 plus 1. So b is equal to half I am getting. B is equal to half. So a and b we got. Now that I can substitute in this equation. Here a and b is present. Substitute the values of a and b in this equation. This equation keep as it is. The second equation becomes putting a is equal to 1 a is equal to 1 and b is equal to half. This equation becomes 2bx square plus ax plus 4 equal to 0 will become, putting b is equal to half, 2 into half into x square plus a, how much? A is 1 into x plus 4 is equal to 0. 2 cancels. What we get is x square plus x plus 4 equal to 0. And they told this equation, after putting the values of a and b, and this equation will have a common root. There is actually a condition in case of quadratic equations. Two quadratic equations are given to you. It can have one common root or it can have both roots as common under different condition. Okay, if both the roots are common for the two quadratic equation, then ratio of the coefficient of x square is equal to ratio of the coefficient of x equal to ratio of the constants. That is the condition. See, observe this equation, x square plus x plus 4 equals 0. For this quadratic equation, b square minus 4ac is negative. This a is 1 here, b is 1, c is 4. If you find b square minus 4ac for this, b is 1 square 1, minus 4 into a is 1, c is 4, 1 minus 16, that is minus 15, less than 0, correct? B square minus 4ac is negative, correct? For a quadratic, if b square minus 4ac is negative, means it has imaginary roots. That means the roots are imaginary. So, and we know that imaginary roots always occurs in conjugate pairs. If alpha plus I beta is a root, then alpha minus I beta is also the root of the same quadratic equation. They told this equation and this equation have a common root. One common root actually. It can't have one common root. It will have both the roots common because the imaginary roots always occurs in conjugate pair. If alpha plus I beta is a common root for these two, then alpha minus I beta is also the common root for both the equation. Two equations can't have one complex root as common. If it has a complex root common, both the complex roots will be common for both the equations. Understood? So I can conclude that these two equations definitely have both the roots as common. Okay, if both the roots are common for the two quadratic equation, then what is the condition we have? Ratio of the coefficient of x square is equal to ratio of the coefficient of x equal to ratio of the constant. Actually, there is one condition. I can add one slide here. I'll show you, I'll write the conditions actually. If you take a quadratic equation like this, a1x square plus b1x plus c1 equal to 0. And another equation is like this, a2x square plus b2x plus c2 equal to 0. If both the roots are common, for these two equations, a quadratic has two roots. Both the roots are same for both the equations. Both roots are common, then the condition is this. Both roots are common. Then what we have is a1 by a2 is equal to b1 by b2 is equal to c1 by c2. This is the condition for two roots, which is both the roots are common. If it has only one root common, then there is one more condition. If one root is common for both the quadratic equations, then what we have, the condition is a1 into c2 minus a2 into c1 the whole square. Extremes you multiply, extremes. a1 into c2 minus a2 into c1 the whole square is equal to a1 b2 minus a2 b1, a1 b2 minus a2 b1, okay, multiplied by b1 c2 minus b2 c1, b1 c2 minus b2 c1, like this we get. That is for one root to be common. Here both the roots are common, this is a condition. Okay, this will be taught to you in detail in quadratic equations chapter. For time being, just I told you. And in this question they told that these two equations have common root. They can't have one common root, both the roots will be common. So I'm applying this condition. Okay, I'm applying this condition. Okay, Why it has both the roots common? Because the quadratic equation has imaginary roots, and imaginary roots always occurs in the conjugate phase. It can't have one root, one imaginary root as common. If imaginary roots are there for a quadratic equation and two quadratic equations have a common root, both the roots should be common. That is the condition. So if you look at these equations, this equation, no? What is the equation here? X square plus x plus 4 equal to 0. Correct? X square plus x plus 4 equal to 0. This equation. And after putting the values of a and b, I got like this. And this equation, cx square plus dx plus e equal to 0. Cx square plus dx plus e equal to 0. Understood? These two equations will have both the roots common because this equation has imaginary roots, and imaginary roots occurs in conjugate pairs. It can't have only one imaginary root as common because the conjugate roots occurs in conjugate pairs. So I'm using this condition for this. So ratio of the coefficient of x square 1 by c is equal to 1 by d is equal to 4 by e. Or you take the reciprocal, c by 1 is equal to d by 1 is equal to e by 4. They asked to find what? They asked to find the ratio d is to c is to e. D is to c is to, therefore d is to c is to e. D is proportional to 1, c is proportional to 1, e is proportional to 4. Required answer is 1 is to 1 is to 4. Option D is the answer. Concept of binomial theorem. How to find sum of all coefficients? Just put x equal to 1. In detail, we'll do it in binomial theorem. Put x equal to 1 and get the value of a. And for b, limiting value, that is integration is there, and you apply L'Hopital's rule and Newton-Leibniz. We got the answer. And limit x tends to 0, log 1 plus x by x is 1. Okay? And apply Newton-Leibniz formula and L'Hopital's rule. Differentiate numerator and denominator separately. And the concept of quadratic equations. All are used in the same question. Okay, multiple concepts are there in this. This is the condition for both the roots to be common, and this is a condition for these two quadratic equations to have only one root common. Understood? Solution is also given to you here. Go on to the next one. Question number 9. Limit x tends to 0, e power 2 times mod of sin x minus 2 times mod of sin x minus 1 divided by x square. Question asked on 31st of January 1st shift 2024. Here what we'll do is first you take 0 by 0 form. If you apply the limit directly, it's very obvious. Limit x tends to 0, e power 2 mod of sin x is there minus 2 mod of sin x minus 1 divided by sin square x. I'll divide by sin square x and multiply by sin square x. Divided by x square was there, correct? Divided by x square written here. Multiply and divide by sin square x. Sin square x also same as mod of sin x square, correct? Sin square x same as mod sin x square, because x square is same as mod x square, and this will become 1, correct? Limit of this will become 1 as x tends to 0, sin x by x 1, sin x by x the whole square is 1. So this part is 1. I won't write that. So now limit x tends to 0, denominator what we have, sin square x is same as mod of sin x the whole square, right? Correct? Both are same. And for e power 2 mod of sin x, I'll apply series expansion, infinite series expansion. E power x what we have? E power x is 1 plus x square by 2 factorial, correct? 1 plus x square divided by 2 factorial etc. up to infinity. Instead of x we got 2 mod of sin x. Replace x by 2 mod of sin x and write the expansion for this. 1 plus 2 mod of sin x plus 2 mod of sin x the whole square divided by 2 factorial. 2 mod of sin x the whole square divided by 2 factorial. Like this it goes on. Other terms I'm not writing it, higher power is not required because the denominator is mod of sin x square, right? Only terms up till mod of sin x square, correct? Other terms not required. Minus 2 mod of sin x minus 1. Denominator this is becoming 1. This is cancelling, correct? 1 plus 2 mod of sin x will cancel. What is left out is this. 2 square is 4. 2 factorial is 2. 4 by 2 is 2. So what we get is limit x tends to 0. limit x tends to 0. 4 by 2 is 2. Mod of sin x square. Rest all terms which I didn't write. Now all those terms will become 0 because sin x cube will be there. Mod of sin x cube divided by mod of sin x square. That will be mod of sin x. As x tends to 0, mod of sin x will become 0. Similarly, other terms will become 0. Correct? So what is left over? 4 by 2 is 2. Mod of sin x square divided by mod of sin x square. Correct? This will cancel. Mod of sin x will cancel. Limit of 2 is 2. This will cancel. Limit of 2 is 2. Answer is 2. 2 into 1, 2. Answer is option D. Hope you understand. Writing the series expansion for e power 2 mod of sin x using this formula. E power x. Correct? Instead of x, we got 2 mod of sin x applied. 1 plus 1 minus 1 add up to 0. 2 mod of sin x minus 2 mod of sin x also will add up to 0. And whatever there here, divide it, get the answer. Solution is given here. 2 into 1 equal to option D is the answer. Next one, question number 10. A function f is defined from real numbers to the open interval 0 to infinity is a strictly increasing function such that limit x tends to infinity f of 7x by f of x is 1. You have to find the value of limit x tends to infinity f of 5x by f of x minus 1 equal to how much? Question asked on 31st of January 2nd shift 2024. This type of question already appeared earlier also. In earlier, before JEE exam was called as AIEEE, during that time the question was asked this type of. Okay. Normally the question repeats. Similar type of questions will be asked. Okay. So working out PYQs is must and must. I'll tell you. Whenever you are preparing for JEE exams, PYQs is must. Okay. Because the function is strictly increasing. And x is approaching to infinity. That means x is a positive number. So we know that x is positive. So x is less than 5x less than 7x. I can write like this. Correct? X is less than 5x less than 7x. It's an increasing order. 7x is bigger. I'm writing only the angles or the values which is present inside the bracket. X is present, 7x present, 5x present. I'm comparing those values. And this implies f of x is less than f of 5x is less than f of 7x. Correct? Because the function is strictly increasing. Strictly increasing means as we increase the value of x, the function value also increases. Correct? X is less than 5x less than 7x implies f of x less than f of 5x less than f of 7x because f is strictly increasing. F is strictly increasing. Now I'll divide this entire inequation by f of x because see denominator f of x is there. F of x is the denominator, right? So you divide the entire inequation by f of x. I'll be using the sandwich theorem here. Sandwich theorem questions are rarely asked. Even in 2023 there was one question on sandwich theorem, correct? There are questions. Even in 2021 they asked question connected to greatest integer function. I've done it. So rarely the questions are asked on sandwich theorem. So I'm sandwiching this f of 5x to lie between f of x and f of 7x because I want to evaluate this limit. I'm dividing this entire inequation by f of x. Divide throughout by f of x. What do you get? F of x divided by f of x less than f of 5x divided by f of x less than f of 7x divided by f of x. Divide by f of x. Entire inequation. F of x by f of x is 1. Correct? 1 is less than f of 5x divided by f of x is less than limit f of 7x divided by f of x. Now we can apply limit for all of this. Apply limit x tends to infinity for this because x tends to infinity is given there. Correct? Limit x tends to infinity for this. Limit of 1 is 1, right? Limit of 1 is 1. Here also apply limit. X tends to infinity. 1 is less than. Limit x tends to infinity. F of 5x divided by f of x is less than. X tends to infinity. What is f of 7x by f of x is given to be equal to 1. This is given to be equal to 1. Limit of 1 is 1. Limit of this is given to be equal to 1. Correct? And this is sandwiched between this and this because limit of this is 1 and limit of this is 1. Limit of this also 1 by sandwich theorem. Therefore, by sandwich theorem I can conclude that the middle one limiting value is also 1. Correct? F of x less than or equal to g of x less than or equal to h of x. Limit x tends to a is some number. Okay, limit of f of x and limit of h of x is L, then limit of the g of x, the middle one, is also L. So limit of this is going to be equal to 1. By sandwich theorem we get limit x tends to infinity, limit x tends to infinity, f of 5x divided by f of x is equal to 1. Answer is option D. Not option D. They asked to find limit x tends to infinity f of 5x by f of x minus 1. No, so answer is 0. Don't conclude 1. I should write this one to left answer because limit x tends to infinity f of 5x by f of x minus 1 is there. And I can substitute, I can write this value. This value is 1. If you apply limit to this and limit to this, limit of 1 is 1, correct? They asked to find what? Therefore, required is limit x tends to infinity f of 5x divided by f of x minus 1, correct? This is what they ask. Apply limit to this, apply limit to this. Limit of this is 1 as shown above. So 1 minus 1 is equal to 0. Limit of this is 1. 1 minus 1 is 0. Limit of 1 is 1 only. 1 minus 1 is 0. Option B is the answer. Not option D, option B. Second option. Not option D, it's option B actually. Mistake here. It's option B. And not written here. This is, you can take this as minus 1 equal to 0. Option B is answer. Okay, make a correction. Option B is answer. Move on to the next one, question number 11. Limit x tends to 0, a x square e power x minus b log of 1 plus x plus c x e power minus x by x square sin x equal to 1. Find out 16 into a square plus b square plus c square. So denominator is x square into sin x. There what we'll do is multiply and divide by x. So that limit x tends to 0, sin x by x is 1. So denominator will become x cube. I want to find the 3 unknowns here, a, b, c. So to find 3 unknowns we need 3 equations. I'll be using the series expansions for e power x, log 1 plus x and e power minus x. And you write the infinite series expansion for those up till x cube because the denominator will be x cube, correct? This type of question we've done many times. Limit x tends to 0, limit x tends to 0, what we have? A x square e power x minus b into log of 1 plus x plus cx into e power minus x divided by x square into sin x divided by x multiplied by x. This is equal to 1. Sin x by x is 1 as x approaches to 0. Denominator is x cube. Write the series expansion for e power x log 1 plus x and e power minus x up till x cube. Our usual technique. Correct? Many times we've done this kind of question. Limit x tends to 0. What we have? Ax square into writing series expansion 1 plus x square by 2 factorial etc. up to infinity. Even x square by 2 factorial is not required because x square into x will become x cube here only, correct? Minus b into log 1 plus x is x minus x square by 2 plus x cube divided by 3 etc. up to infinity plus cx into e power minus x is 1 minus x plus x square by 2 factorial minus x cube by 3 factorial etc. up to infinity, correct? Divided by denominator is x cube. Denominator is x square into x cube is equal to 1. Now you can connect the terms with x. Here I get cx into 1, cx, coefficient of x c. Here minus bx, here there is no x term. So connect the terms with x. There is no constant term in the numerator, correct? So connecting the coefficients of x together, limit x tends to 0. What we have? X into, here there is no x term. Here coefficient of x is minus b. Here coefficient of x is c minus b divided by x cube plus x square into collect the terms with x square coefficient is a, correct, a, minus into minus plus x square coefficient is b by 2 plus b by 2, here cx into minus x minus cx square, correct, coefficient of x square, that is minus c divided by x cube, correct, plus next connect the terms with x cube, coefficient of x cube I'm collecting now, here x into x square, oh correct, no, x square, here x into x square is x cube, so coefficient of x cube is a there, correct, a, x cube into a, here x cube term is 1 by 3, so minus b by 3 I'll get, minus b by 3, and here x cube term will be 2 factorial is 2, c by 2, c by 2, close the bracket, divided by x cube, plus other terms will become 0, x power 4 into something by x cube, that is x into something, x is approaching 0, correct, so other terms I don't write, that all those terms are 0, is equal to 1. And if you cancel 1x here, denominator is becoming x square, denominator is becoming 0, that means limit does not exist. So limit to exist, already limit is 1, limiting value is 1. For limit to exist, we insist the condition that c minus b should be 0. C minus b equal to 0, that means c is equal to b, that is b is equal to c. And again same story here, denominator here x square cancels, denominator becomes x, and x is approaching to 0, denominator is becoming 0, so numerator should become 0, correct, otherwise limit does not exist. So a plus b by 2 minus c equal to 0. Here x cube cancels, limit of this, that is limit of a constant is constant, that is a limiting value, that should be equal to 1, correct, a minus b by 3 plus c by 2, that should be equal to 1, and whatever terms are in right, all those terms are 0 here, correct, the limiting value of that is going to be 0. So b is equal to c, I can use that equation and get the values, this becomes c is equal to b, no, use this equation, this a plus b by 2 minus c is same as b, so minus b is equal to 0, b by 2 minus b is minus b by 2, so a equal to b by 2 I'll get a is equal to b by 2, correct, a is equal to b by 2. So I'll use b equal to c in this also, what we'll get in that case, a minus b is c, correct, here I got a is equal to b by 2 I got, no, b is equal to c, that means you replace c by b, minus b by 3 plus b by 2 is equal to 1, correct, putting c is equal to b. In that case what I get, you multiply the entire equation by LCM of 3 into, that is 6, I'll get 6a minus 2b, correct, minus 2b multiplying by 6, that becomes 3b is equal to 6, correct, and a is b by 2, a is b by 2, 6 into b by 2, 6 into b by 2 is 3b, correct, putting a is equal to b by 2 here, 6 into b by 2, and 3b minus 2b is b is equal to 6, 6 into b by 2, that is 3b plus b, 4b I'll get, correct, 4b equal to 6, this is 3b plus b, 4b is equal to 6, that means b is equal to 3 by 2, b is equal to 3 by 2, b is 3 by 2 means c also 3 by 2, because b is equal to c, so c is also 3 by 2. And what is a? A is b by 2, b is 3 by 2, 3 by 2 by 2 is 3 by 4, everything we got. So I can write the answer here only, 16 into a, how much, 3 by 4, 3 by 4 square is 9 by 16, b how much, 3 by 2, 3 by 2 square is 9 by 4, c is also 3 by 2, 3 by 2 square is 9 by 4, how much you get, 16 into 9 by 16 is 9, plus 4 ones are 4 fours are, 4 into 9 is 36, here also plus 36, 36 plus 36, 72 plus 9, 81 is answer, numerical type question, answer is 81, hope you understand this. Series expansion, answer is 81, b is 3 by 2, c is 3 by 2, a is 3 by 4 we got. Detailed solution is given to you. Move on to the next one. Question number 12. Question was asked on 4th of April, first shift 2024. Limit x tends to 1, 5x plus 1 power 1 by 3 minus x plus 5 power 1 by 3 divided by 2x plus 3 power half minus x plus 4 power half is given to be equal to m root 5 by n into 2n power 2 by 3. GCD of m comma n is 1. Want to find 8m plus 12 and numerical type question. If you apply the limit directly, x equal to 1, 5 into 1, 5, 5 plus 1, 6, 6 power 1 by 3, minus 1 plus 5, 6, 6 power 1 by 3. This becomes 6 power 1 by 3 minus 6 power 1 by 3 divided by 2 into 1, 2, 2 plus 3, 5, 5 power half minus 5 power half, 1 plus 4, 5, 5 power half. So it becomes 0 by 0 form. 0 by 0 form. So you can apply L'Hopital's rule. Differentiate numerator and denominator separately. Apply L'Hopital's rule. Differentiate the numerator and denominator separately. What do you get? Limit x tends to 1. Derivative of 5x plus 1 power 1 by 3 is how much? Derivative of x power n formula. Also apply chain rule. Derivative of x power n into x power n minus 1. 1 by 3 into 5x plus 1 to the power 1 by 3 minus 1. That is minus 2 by 3 into derivative of 5x plus 1, 5. Minus derivative of x plus 5 power 1 by 3 is 1 by 3 into x plus 5 to the power 1 by 3 minus 1 minus 2 by 3 into derivative of x plus 5, 1. Divided by denominator is derivative of 2x plus 3 power half is half into 2x plus 3 to the power half minus 1, that is minus half, into derivative of 2x plus 3, 2, minus derivative of x plus 4 power half is 1 by 2 into x plus 4 to the power half minus 1, that is minus half, into derivative of x plus 4, 1. Now apply the limit at this stage. You can get the answer and compare with this, get the values of m and n, then find 8n plus 12n. Quite simple question here. Applying the limit directly here, 5 by 3 into 5 by 3 into 5 into 1, 5, 5 plus 1, 6, 6 power minus 2 by 3. Here, minus 1 by 3 into 1 plus 5, 6 power minus 2 by 3. Denominator is here, 2 cancels actually, 2 will cancel, 2 into 1, 2, 2 plus 3, 5, 5 power minus half. Here, half into 1 plus 4, 5, applying limit x equal to 1, 1 plus 4 is 5, 5 power minus half. And you can take the common terms, correct? Numerator 6 power minus 2 by 3 is common. 6 power minus 2 by 3 is common, correct? So 5 by 3 minus 1 by 3 is 4 by 3. And in the denominator 5 power minus half is common. 5 power minus half is common. That is 1 minus half is half. Correct? 5 power minus half will go up. 4 by 3 divided by 1 by 2. That becomes, this 2 will go up. It becomes 8 by 3. Correct? 8 by 3. This 2 goes up. 8 by 3. And 5 power minus half, take it up. It becomes 5 power half. 6 power minus 2 by 3, bring it to denominator, it becomes 6 power 2 by 3, correct? 5 power half is root 5, in that form I am getting C. This is equal to 8 into root 5 divided by 3 into, I can write 6 as 2 into 3, correct? 2 into 3 to the power of 2 by 3, correct? Compare. M root 5 by n into 2n power 2 by 3. Compare. M how much? 8. If you compare this and this, denominator see n into 2n power 2 by 3. If you observe, n is 3 here, correct? N is 3. 2 into n. 2 into n here. 2 into 3. If you compare this and this is exactly what? M root 5 divided by n into 2n to the power 2 by 3. If you compare, what you get? M is 8 and n is 3, correct? M is equal to how much? 8 and n is equal to 3. What we want to find, therefore 8m plus 12n. 8m plus 12n. 8 into value of m is 8. Value of n is 3. 8 into 8 is 64. 12 into 3 is 36. 64 plus 36. 100 is answer. Numerical type question asked. Answer is 100. Hope you understand. Just apply L'Hopital's rule, 0 by 0 form. Differentiate numerator and denominator separately and compare with the given right hand side. And you write in the simplest form so that GCD of m comma n is 1. GCD of 8 and 3 is 1. Correct? GCD is greatest common divisor of 8 and 3, which is equal to 1. So required answer is 100. Solution is also given to you. If you want, you can take a screenshot of this. Detailed solution is given you. Move on to the next one. Question number 13. Again, integration sign is there here. Limit of x tends to 0 is there, f of x by x cube. So limit is there, integration is there. It's a combination of two things. L'Hopital's rule and Newton-Leibniz formula. F of x is given, that you can substitute there. So what we want to find is limit x tends to 0. Limit x tends to 0. F of x is integral from 0 to x. Correct? T plus sine of 1 minus e power t dt divided by x cube. Correct? X cube. If you apply limit directly, integral from 0 to 0. Lower limit is 0, upper limit also 0. Integral from 0 to 0 is 0. Denominator is also 0. 0 cube is 0. So 0 by 0 form. It takes 0 by 0 form. Correct? So you can apply L'Hopital's rule. Differentiate numerator and denominator separately. Apply d by dx for this. Differentiate the numerator. Differentiate the denominator. Correct? And integration and differentiation is going to cancel. Integration and d by dx is going to cancel. Substitute the upper limit, differentiate the upper limit. What do you get? Limit x tends to 0. In place of t, put the upper limit x plus sine of 1 minus e power x into derivative of x is 1. And lower limit is 0. Derivative of 0 is 0. Correct? Divided by derivative of x cube is 3x square. Correct? Now you can apply the limit. It becomes 0 by 0 still. If you apply limit here, x equal to 0, e power 0 is 1, 1 minus 1 0, sine 0 0, 3 into 0 0, again 0 by 0 form. Again apply L'Hopital's rule. This also takes 0 by 0 form. So we can apply L'Hopital's rule. Differentiate numerator and denominator separately. Again apply L'Hopital's rule. I'll write LH rule here. Okay. Limit x tends to 0. What we have? Derivative of x is 1. Derivative of sine is cos. Cos of 1 minus e power x into derivative of 1 minus e power x. That is minus e power x divided by, correct? 1 plus, I think I should multiply this one. Cos of 1 minus e power x into minus e power x. Derivative of 3x square is 6x. Correct? Still it is in 0 by 0 form. If you apply limit directly, no, denominator is 0. Numerator also, e power 0 is 1, 1 minus 1 0, cos 0 is 1, 1 into, this is e minus e power 0, minus 1 into 1, minus 1 plus 1 0. Again apply L'Hopital's rule. Again apply L'Hopital's rule. For the third time applying L'Hopital's rule. Again apply L'Hopital's rule, LH rule, alright. Differentiate the numerator and denominator separately. Okay. What we get? Limit x tends to 0. Differentiating the numerator and denominator separately. Derivative of 1 is 0. Here apply the product rule. First into derivative of second plus second into derivative of first. That is cos of 1 minus e power x into derivative of minus e power x is minus e power x plus second function, keep as it is, minus e power x into derivative of first, derivative of cos is minus sine of 1 minus e power x into derivative of 1 minus e power x, that is minus e power x. Correct? So I'll get minus sine of 1 minus e power x, correct, into derivative of 1 minus e power x, that is minus e power x. No space to write. I'll rub this. I'll write again. Okay, there is no space actually. It is smaller. It was not wrong, it was correct only, but there is no space. So I'm rubbing and writing it once again. Derivative of 1 is 0. Write the first function as it is. First function is what? 1 plus, derivative of 1 is 0. Derivative of, I'm applying the product rule for this. Derivative of 1 is 0. This is product of two functions here. Okay. So what you can do is apply product rule there. Cos of 1 minus e power x. Cos of 1 minus e power x into derivative of minus e power x is minus e power x. Okay. First into derivative of second plus second into derivative of a second function minus e power x into derivative of cos of 1 minus e power x is minus sine of 1 minus e power x into derivative of 1 minus e power x, that is minus e power x, divided by derivative of 6x is 6. Now we can apply limit at this stage. X equal to 0. E power 0 is 1. 1 minus 1 0. Cos 0 it becomes cos 0 into minus e power 0, that is minus 1. Here minus into minus is minus. E power 0 is 1 and e power 0 is 1. 1 minus 1 0. Sine 0 is 0. Gone. Correct. Divided by 6. Cos 0 is again 1. 1 into minus 1. Minus 1. So answer is minus 1 by 6. Option A is the answer. Minus 1 by 6. Option A is the answer. Move on to the next one. Question number 14. A is greater than 0. Be a root of the equation 2x square plus x minus 2 equal to 0. Limit x tends to 1 by a 16 into 1 minus cos of 2 plus x minus 2x square by 1 minus ax the whole square equal to alpha plus beta root 17. Alpha and beta are integers. Find alpha plus beta. Question asked on 5th of April, second shift 2024. So a is positive and it is a root of this equation. Want to find limit x tends to 1 by a. Observe the bracket here, 2 plus x minus 2x square. The quadratic present inside this bracket is not same as this. Correct? And I can find the root of this, the positive root of this I can find out by using the formula method. Using the formula method, minus b plus or minus root of b square minus 4ac by 2a. You can find the root of this, the positive root of. That we shall do first. Because a is a positive root, solve this equation. 2x square plus x minus 2 equal to 0. Solving this equation, what we get? X is equal to minus b minus 1, correct, plus or minus root of b square minus 4 into a into c divided by 2a divided by 2 into 2. That is equal to minus 1 plus or minus into minus plus 4 2s are 8, 8 2s are 16, 16 plus 1 17. Root 17 divided by 4. So I want a as a positive root. Since a is positive, take a is equal to minus 1 plus root 17 by 4. Minus 1 plus root 17 divided by 4. Because a is positive. A is greater than 0. Minus 1 plus root 17 divided by 4. So a is we got. And observe, if a is a root of this equation, if you replace x by 1 by x, I'll get this expression 2 plus x minus 2x square. That is another observation here. 2x square plus x minus 2 equal to 0 is there. If you replace x by 1 by x, replace x by 1 by x, what we get? 2 into 1 by x the whole square plus 1 by x minus 2 equal to 0. Multiply the entire equation by x square, same as taking LCM. So 2 plus x minus 2x square equal to 0. That is what I get. 2 plus x minus 2x square. So if a is a root of this equation, I can conclude that 1 by a is a root of this equation. So 1 by a is going to be the root of this quadratic. A is root of this quadratic, 1 by A is root of this quadratic, because from this this equation is got from this equation by replacing x by 1 by x. If x is root of this, 1 by x is root of this. Understood? So A is root of this equation, so 1 by A is going to be the root of this equation. So limit x tends to 1 by A is there. And because it takes 1 minus cos of some quadratic by quadratic, I'll be using this familiar result. Limit theta tends to 0, 1 minus cos theta by theta square half. I'll be using this. Limit theta tends to 0, very familiar result. 1 minus cos theta divided by theta square is equal to 1 by 2. I'll be using this limit theorem. Limit theta tends to 0, 1 minus cos theta by theta square equal to half. I'm using this. Okay. And also because 1 by A is a root of this, for this quadratic, 1 by A is a root. Okay. I can write this quadratic as, 2 plus x minus 2x square as minus 2 you take out into, because 1 by A is a root of that, what I can write is x minus 1 by A. Take other root as 1 by B. So x minus 1 by B. X minus 1 by A into x minus 1 by B. Minus 2 is taken out, so that coefficient of x square inside the bracket is 1. This is identically equal to, I can write. This quadratic could be written like this. Because 1 by A is a root of this, I can take the coefficient of x square out and express like this. So this is a usual way of writing the quadratic in terms of the roots. Now with this much in our hand, what I can do is I'm using this result. Limit theta tends to 0, 1 minus cos theta by theta square equal to half. Concentrate on this here. Okay. And also I can take A common here first. So this is equal to, now you see, limit x tends to 1 by A. Limit x tends to 1 by A. What I can write is 16 into 1 minus cos of this bracket is there, 2 plus x minus 2x square. That is what I can write is, from this I'll write minus 2 times x minus 1 by A into x minus 1 by B. Divided by, here you take A common. Nothing is common, still I'm taking out. A comes out, A square comes out. A square into what is left out, 1 by A minus x the whole square. And 1 by A minus x the whole square is same as x minus 1 by A the whole square, correct? Because 3 square is same as minus 3 square. So square is there, means I can write like that. 16 by A square is a constant that you can keep outside. 16 by A square into limit x tends to 1 by A, and we know cos of minus theta is same as cos theta. Cos of minus 2 into x minus 1 by into x minus 1 by b, same as cos of 2 into x minus 1 by x minus 1 by b. That also will apply. 1 minus cos of 2 into x minus 1 by A into x minus 1 by b, correct? Divided by 1 by A minus x the whole square is same as x minus 1 by A the whole square. And to apply this theorem, here what is the angle present? The angle present is 2 into x minus 1 by A into x minus 1 by B. Square of that should be present in denominator, correct? So I'll multiply and divide by what is not there. X minus 1 by A square is there already. 2 square I want, and x minus 1 by b square I want. So you multiply and divide by 2 square into x minus 1 by b the whole square. Okay, then you can use that result. Theta tends to 0, 1 minus cos theta by theta square equal to half. I'm using that result. So for that, that's equal to, I can write it as is equal to 16 divided by a square. Limit x tends to 1 by a. Limit x tends to 1 by a. X approaches 1 by a means x minus 1 by a is approaching 0. So this angle is tending to 0. That condition is also required. Correct? 1 minus cos of what we have, 2 into x minus 1 by a into x minus 1 by b, correct, divided by what we have, I want square of 2, that is 2 square into x minus 1 by a square is already present into x minus 1 by b square multiply by 2 square into x minus 1 by b the square. Okay. Otherwise, I'll store in the next slide. There is no space here. I'll write in the next, that is only better. I'll rub all these things because there is no space here. I'll write in the next page, correct? Multiply and divide by 2 square into x minus 1 by b the whole square. So what we have is 16 by a square, 16 divided by a square, limit x tends to 1 by a, correct? 1 minus cos of 2 into x minus 1 by a into x minus 1 by b, correct? Divided by x minus 1 by the whole square was there. What I am doing is multiply by 2 square into x minus 1 by b the whole square. These two are not there. To balance it, you multiply by 2 square into x minus 1 by b the whole square. Correct, no? This much we had. Multiply and divide by 2 square into x minus 1 by b the whole square. And using this result, theta tends to 0. 1 minus cos theta by theta square is half. Correct? This much is going to be equal to half as theta tends to 0. This becomes half. And you can apply limit for remaining terms. 16 divided by a square into half into 2 square is 4. And applying limit for this, x is approaching 8. So it becomes 1 by a minus 1 by b the whole square. 2 ones are 2 twos are 2 into 16 is 32. 32 divided by a square into 1 by a minus 1 by b the whole square. Take LCM AB. AB is LCM. So I get b minus a the whole square. Correct? A already we got. Correct? I shown the solution of a here. A is minus 1 plus root 17 by 4. B is equal to minus 1 minus root 17 by 4 I'll take. Correct? That's the other root. And otherwise a and b are the roots of this equation. No? A and b are the roots of this equation, means product of the roots. AB is going to be constant term by coefficient of x square. That is required here. Constant term AB is product of the roots. Minus 2 by 2. That is minus 1. I'll be using that. Okay. So AB is required. And a square I can substitute. That is 32 divided by, what is the value of a I got? The value of a I got it as minus 1 plus root 17 by 4. Correct? I can substitute here. Minus 1 plus root 17 the whole square divided by 4 square, that is 16. And b minus a. B how much? B is minus 1 minus root 17. A is minus 1 plus root 17. AB how much we got? AB is minus 1, correct? Minus 2 by 2, minus 1. AB is minus 1. This entire thing square. Yeah, minus 1 plus 1 is going to cancel. Minus root 17 minus root 17 minus 2 root 17. This that is 16 will go up. So I'll get the answer like this. 32 into 16. Here minus root 17 minus root 17 minus 2 root 17 minus 2 root 17 divided by minus 1 the whole square and divided by what we have there, root 17 minus 1 the whole square. This we can expand it. A minus b whole square formula. A square plus b square minus 2ab. Correct? Here minus minus will cancel. 2 square is 4 and root 17 square is 17 there. 32 into this is 32 into 16. Correct? Two square is 4 there. 4 into root 17 square is 17 divided by 18 minus 2 root 17. I can take 2 common there. Denominator will become 9 minus root 17. 1 2 is cancelled. This becomes 8 here. Correct? 8 into 4 is 32. 32 into 32 into 17. You can multiply and divide by 9 plus root 17, the conjugate. So that denominator will be a minus b into a plus b, a square minus b square. That is 81 minus 17. Correct? This is 9 plus root 17, keep as it is. This is 32 into 32 into 17 into 9 plus root 17. Denominator will be 64 here. Correct? This is 64 actually. 32 minus 17, 81 minus 17 is 64. 32 ones are 32 twos are 2 ones are 2 16s are 16 into 17 I'm getting, that is 272. Correct? 272 into 9 plus root 17. What we are getting actually, what is given, I want in terms of root 17, no? Root 17. (32) 2 ones are 2 twos are 32 by a square into, correct, no, b minus 16 by a square. This became half 2 square 4, 1 by a minus 1 by b the whole square, ab square, ab is minus 1, minus 1 square is 1. (16) 32 into 16. We get the answer like this actually, 32 by a square, a minus b the whole square, ab the whole square. 170 is the answer, 153, 17 into 9 I should get. 17 into 9 I'm getting, 17 into 9, 153. I should have cancelled this. This is from where? 32 into 16. This is 8, 8 into 4 is 17, 2 root 17. 2 root 17 square. 4 into 17, 8 4s are 32. Small mistake, otherwise I'll do this method. Just a minute. I'll use the method of simplification here. I'll use b minus a the whole square, as that is only better. I think something has gone wrong in this calculation, I think. B minus a the whole square is same as a minus b the whole square. A minus b the whole square is a plus b whole square minus 4ab, correct? That method only I'll do. This is a very lengthy question actually, correct? B minus a whole square is same as a minus b whole square. A minus b whole square is a plus b whole square minus 4ab, correct? Divided by ab the whole square. This method is only better, I think. And AB is how much? Minus 1, correct? AB is minus 1 and A plus B is minus half, correct? Minus 1 by 2. AB is minus 1 and A plus B is how much? Minus 1 by 2. I'll be using these two. A plus B is minus half and AB is minus 1. So this 16 goes up, 32 into 16, 32 into 16 divided by root 17 minus 1 the whole square. Correct? Here a plus b is minus half square is 1 by 4, minus 4 into ab is minus 1 divided by ab is minus 1 square. This is 1 by 4 plus 4, that is 17 by 4. Correct? 32 into 16. Here 1 by 4 plus 4, that is 17 by 4, and denominator minus 1 square is 1. This is root 17 minus 1 the whole square. If I expand, what do you get? 17 plus 1 minus 2 root 17. 4 ones are 4 fours are. 32 into 4 is 128 into 17 divided by 18 minus 2 root 17. We can take 2 common and cancel. If you take 2 common from this, denominator becomes 9 minus root 17. 2 ones are 2 64s are. This becomes 64 into 17. You rationalize this, multiply and divide by 9 plus root 17, and denominator will be what? Denominator will be a square minus b square. 9 square is 81. 81 minus root 17 square is 17, and this is 64 into 17. Here it is 9 plus root 17. This 81 minus 17 is 64. 64 will cancel. What we get is 17 into 9 plus root 17. So I'm getting the answer as, I'll write here, 17 into 9, that is 153. correct, plus 17 root 17 root 17, that is 153 plus 17 root 17. So that we can compare with alpha plus beta into root 17 as given, correct, given alpha plus beta into root 17. So alpha is, if you compare, alpha is 153, if you compare, alpha is 153 and beta is 17. Therefore alpha plus beta, 153 plus 17 is 170. Alpha plus beta is 170. That's the answer. Solution is given here. Answer is 170. Detailed solution is given. Quite lengthy one this is. If you want to explain once again. First we start with A is the root of this equation. Find the root of this equation by using the formula method. Okay. Formula method you can apply and get the roots A and B. A is a positive root. So A is root 17 minus 1 by 4. B is minus 1 minus root 17 by 4. And also you write A and B are the roots of this equation. Product of the roots is C by A. Constant term by coefficient of x square. Sum of the roots is minus half. So replace x by 1 by x and this equation will be changed to this equation. If you replace x by 1 by x, I'll get this. So this quadratic is identically equal to minus 2 into x minus 1 by into x minus 1 by b. So that 1 by a and 1 by b are the roots of this equation, and I'll be using this kind of simplified form in this here. Okay. 2 plus x minus 2x square, I'm going to write like this. And cos of minus theta is cos theta, we know. So 1 minus cos theta by theta square, using this result. So multiply and divide by the angle present here. Square of this should be present in the denominator. What is not there, you multiply and divide. Okay. So 2 square I want, and x minus 1 by b the whole square I want. Multiply and divide by that, and use 1 minus cos theta by theta square equal to half, and simplify it. Go on, simplify like this. More simplification is involved here. X is approaching to 1 by a. So 1 by a minus 1 by b the whole square. Take LCM and simplify. B minus a the whole square is same as a minus b whole square. A minus b whole square is a plus b whole square minus 4ab. Go on, simplify and compare. Get the values of a, alpha and beta. Alpha is 153, beta is 17. So then alpha plus beta is 170. Quite lengthy question this is. Next one, question number 15. Can you try this? Limit x tends to 0. Same type of question was asked in 2021 also, similar to this. If you apply the limit directly, it becomes 0 by 0 form. Denominator is 0, 0 square. Numerator also cos 0, 1, cos 0, 1, 1 into 1 into 1 into 1. So 1 minus 1, 0, 0 by 0 form. So we can apply L'Hopital's rule. Differentiate numerator and denominator separately. Limit x tends to 0. Denominator becomes 0, 0 by 0 form. So apply L'Hopital's rule. Apply L'Hopital's rule. Differentiate numerator and denominator separately. If you differentiate the denominator, derivative of x square is 2x. I will consider this numerator term separately and differentiate it. Okay, this part, derivative of 1 is 0. I will consider this part, cos x into root of cos 2x into cube root of cos 3x, etc. 10th root of cos x. It is product of 10 cos functions, correct? So let that expression be equal to y. Let y be equal to what? Cos x into root of cos 2x into cube root of cos 3x, etc. Continuing like this, 10th root of cos 10x. Like this we have product of 10 cos functions. If you want to differentiate this, I can apply product rule for 10 functions. Product of 10 functions, correct? But it becomes lengthy. So what we'll do is we'll make use of log. Log, if you apply on both sides, log of the product is sum of the log. Log of AB is log A plus log B. Log of the product is sum of the log, correct? So I can apply log on both sides, use the property of log so that it becomes easy to differentiate. So I'm differentiating the numerator and denominator separately, right? So to differentiate the numerator, derivative of 1 is 0. To differentiate this, I'm taking log on both sides and using the property of log and then differentiating. Understood? So log y is equal to log of, what we have is cos x into root of cos 2x into cube root of cos 3x. Like this it goes on. 10th root of cos 10x. All these things you should do the mind calculations. You can't take much time like this. I am taking more time. I am explaining. I am doing it in detail. We can do it in lesser time, definitely. Log of the product is sum of the log. So it becomes what? Log of cos x plus log of root cos 2x. That is log of cos 2x to the power half, correct? Root means power half. Plus log of cube root of cos 3x means cos 3x to the power 1 by 3. Power is 1 by 3 plus dot log of 10th root. 10th root means to the power 1 by 10. Cos 10x to the power 1 by 10. The power can be brought down and then differentiate it. Correct? Log of cos x plus half log of cos 2x plus 1 by 3 log of cos 3x, etc. Last term is 1 by 10 into log of cos 10x. Differentiate with respect to x on both sides. Differentiate with respect to x on both. Derivative of log y is 1 by y into y dash. Derivative of log y is 1 by y into y dash. Derivative of log of cos x, 1 by cos x into derivative of cos x is minus sin x. Correct? 1 by cos x into derivative of cos x minus sin x. You know, derivative of log x is 1 by x. Derivative of log of cos x, 1 by cos x into derivative of cos x minus sin x. Half into, here derivative of log of cos 2x is 1 by cos 2x into derivative of cos 2x minus sin 2x into derivative of 2x is 2 plus 1 by 3 constant keep as it is, constant into variable, constant keep as it is. Derivative of log x 1 by x, derivative of log of cos 3x 1 by cos 3x into derivative of cos 3x minus sin 3x into derivative of 3x is 3. Like that, you go on, continue. Last term is 1 by 10 into derivative of log of cos 10x, 1 by cos 10x into derivative of cos 10x is minus sin 10x into derivative of 10x is 10. Correct? See here, 2 cancels, 3 cancels, 10 cancels, sin by cos is tan. Correct? So y dash is equal to, I'll get y dash is equal to y into, what is y? Y is this entire product. It's the entire product. So y dash is y into, y is cos x into root of cos 2x into cube root of cos 3x, correct, etc. 10th root of cos 10x, that is your y, into what we have, minus tan x, minus tan 2x, sin by cos tan. Here sin by cos tan everywhere, and minus sign you can keep outside. Minus means minus 1, correct, into sin by cos is tan x plus tan 2x plus tan 3x, etc. tan 10x. That is their derivative. That is the derivative of this, correct? So applying L'Hopital's rule for this, differentiate numerator and denominator separately. 2 is constant, you can keep outside if you want. Okay, I can show it here itself, the derivative part. Limit x tends to 0, correct? Limit x tends to 0. 2 into derivative of 1 is 0, correct? Derivative of 1 is 0. And if you differentiate this, that is what I shown, taken separately. This entire expression is taken as y and differentiate, and I got like this, correct? That will be equal to what? Minus. That minus will get multiplied. Already there is minus sign, and derivative of this entire product also contains some minus. So minus of minus will become plus, correct? So that entire thing into tan x plus tan 2x plus tan 3x, etc. Correct? And you can apply limit for this. If you apply limit for this entire thing, correct, it becomes 1. Cos 0 is 1. Better I'll show in the next one. Next page I'll show you, because there is no space here. Correct? It becomes confusion. Otherwise, in detail I can show it in the next page. So derivative we got, correct? I am differentiating now the numerator and denominator. So what we have is limit x tends to 0. 2 you can keep outside. Limit x tends to 0. What we have is 1 minus cos x into root of cos 2x, correct? Cube root of cos 3x, etc. Continue like this. 10th root of cos 10x we had, correct? Divided by x square. This was the question. Because I am applying L'Hopital's rule, I am differentiating the numerator and denominator separately. Correct? Derivative of 1 is 0. And derivative of this entire thing, that is what we did in the previous one. Correct? That is what we did. Derivative of this entire thing is shown here. That is what we got here. Cos x into root of cos 2x, cube root of cos 3x, etc. 10th root of cos 10x into minus 1 into this bracket. That I'll write. This minus into minus will become plus. This minus will get multiplied with this minus. That becomes plus. So I'll write plus here. Okay. Minus of minus plus. Derivative of this is what? Same thing you write. Cos x into root of cos 2x into cube root of cos 3x, etc. Like this goes on. 10th root of cos 10x. Correct? Into tan x plus tan 2x plus tan 3x, etc. tan 10x, correct, etc. tan of 10x divided by derivative of x square is 2x. And if I apply limit for this, cos 0 is 1, cos 0 1 everywhere, this entire thing is 1. This entire bracket is 1, putting x equal to 0, cos 0 1, 2 into 0 0, cos 0 1, root 1 is 1, 3 into 0 0, cos 0 1, cube root of 1 1. This entire thing becomes 1, 1 into 1 into 1 into 1 1. So this is 1. And you separate the terms. Here there are 10 functions, 10 tan functions. Each term you divide by 2x. This entire thing became 1. I won't write that. So you can cancel this 2 and 2. This 2 and 2 will be cancelled. So what is left is limit x tends to 0. Again I'm telling this entire thing became 1. So what is left is tan x divided by x plus tan 2x divided by x, correct, plus tan 3x divided by x. Same type of question is found in Singh's book, I think. I've seen this kind of question, etc. Tan 10x divided by x. And we know limit x tends to 0, tan x by bx, a by b. We know this limit theorem, trigonometric function. Limit of trigonometric function here. Limit x tends to 0, tan ax divided by bx is equal to what? A by b. I'll be using this. Coefficient of x is a, coefficient of x is b, so a by b. So tan x by x is 1 as x tends to 0. Limit x tends to 0, tan 2x by x, 2 by 1, 2. Correct? Coefficient of x2, coefficient of x1, coefficient of x3, coefficient of x1, 3 by 1, 3. Like that it goes on. Here 10 by 1, 10. This is sum of the first 10 natural numbers. Summation of 10. Summation of 10 is what? 10 into 10 plus 1 divided by 2. 2 ones are 2, 5 are 5 into 11, 55 is the answer. Same type of question was asked even in 2021. I remember. Exactly, not exactly the same, somewhat similar, but this type of differentiation was not there, not so lengthy. Only they gave 1 minus cos x into square root of cos 2x, only that much was it, divided by x square. Okay, there we got the answer as 3 by 2 something like that. E power 3 by 2, 2 into 3 by 2 something was there like that. It was in the form of 1 to the power infinite. I remember exactly same type of question was asked. So use of log and differentiating. To differentiate this product, we use log and simplify, then apply L'Hopital's rule and get the answer. Understood? Hope you understand this. If you want, I can generalize this. Generally, I can write it as 2 times, if they give in general 2 times limit x tends to 0, 1 minus cos x into root of cos 2x into cube root of cos 3x. Like this it goes on, nth root of cos nx, correct, divided by x square is there. Then answer is going to be summation of n, that is n into n plus 1 by 2. If you use this, you can get the answer. 2 should be there, don't forget. If 2 is not there, then it's not possible. Suppose I ask a question, 2 times limit x tends to 0. If 2 is not there, then you take divide by 2. Summation n by 2. That becomes n into n plus 1 by 4 it becomes. Understood? You can add one more slide and give you as important note. 2 times limit x tends to 0. What we had the question? 1 minus cos x into root of cos 2x into cube root of cos 3x. Like this it goes on. Nth root of cos nx divided by x square is equal to what? Summation of n. That is n into n plus 1 divided by 2. For example, if I ask a question like this, I can ask another question. 2 times limit x tends to 0. You don't have to do this if it is asked once again, correct? Because already appeared 2 times this type of question. Cos x into root of cos 2x into cube root of cos 3x. Like this it goes on. 20th root of cos 20x, okay, divided by x square. If this is a question, what is the answer? Directly, because n is 20, it becomes summation of 20. Summation of 20 is what? 20 into 20 plus 1 divided by 2. 2 ones are, 2 tens are. 10 into 21, that is 210. Answer is 210 for this. Summation of 20. If 2 is not there, it becomes divide by 2. 105 becomes in that case. Please make a note of this important shortcut. Don't have to do all those such a big lengthy one. Directly you can answer. Okay, I'll be revising these limits after I finished all the PYQs. Once again, I will complete all the PYQs of all the chapters. Then I'll be revising also in short. Okay, that time I'll give more results for JEE exams. Shortcuts I can give you. Solution is also given to you. Answer is 55 we got, correct? The answer 55 we got. Move on to the next one. Question number 16. Alpha and beta are given are the roots of the quadratic equation. Find 12 times log of a plus b. Question asked on 8th of April, second shift, 2024. Alpha is given. Limit x tends to 0 plus. Alpha is given as limit x tends to 0 plus e power root of tan x minus e power root x by root of tan x minus minus root x. What I'll do is if you apply limit directly, it becomes 0 by 0 form. So what we'll do is we'll use the limit of exponential function. We can't apply L'Hopital so easily because it takes 0 by 0 form, correct? We'll use limit of exponential function. Nothing is common actually, but still I'll take e power root x out. E power root x is taken out from the numerator. To balance it, you divide by e power root x. E power root of tan x divided by e power root x minus 1, correct, divided by root of tan x minus root x. And what I'm doing is I'm making the power and the denominator same. This is equal to limit x tends to 0 plus limit x tends to 0 plus e power root x into what is e power root of tan x by e power root x? That is e power root of tan x minus root x, correct? E power x by e power y is e power x minus y minus 1 divided by root of tan x minus root x. Root of tan x minus root x. E power x by e power y is e power x minus y. As x tends to 0 plus this angle, this power is tending to 0. Power and denominator both are same. I made it same so that I can use this theorem. Limit x tends to 0, e power x minus 1 by x is 1, right? I'm using this. E power x minus 1 by x is 1. The power and denominator both are same. And as x tends to 0 plus, both the power and the denominator is approaching 0. So I can use this result, correct? This entire thing becomes 1. This entire thing is approaching 1 using this x. Here root of tan x minus root x. Root of tan x minus root x. So exactly in this form. So, and this becomes e power root 0. Root 0 is 0. E power 0 is 1. 1 into 1 is equal to 1. So we get alpha is equal to 1. Beta is taking 1 to the power infinity form. See, sine 0 0. 1 plus 0 is 1. Half into cot 0 is infinity, correct? So beta is taking 1 to the power infinity form. So you know the formula for 1 to the power infinity, already used many times. F of x power g of x as x tends to a. What is the formula? E power limit x tends to a, g of x into f of x minus 1. I'm using that. Beta is e power limit x tends to 0. Limit x tends to 0. G of x means write the power first. Half cot x g of x into f of x minus 1. 1 plus sin x minus 1. Correct? That is equal to e power limit x tends to 0. Half into plus 1 minus 1 will add up to 0. Sin x into cot x. Cot x is 1 by tan. And you know sin x by tan x is 1 as x tends to 0. This approaches to 1. Because we have the theorem sin x by x 1 as x tends to 0, tan x by x equal to 1 as x tends to 0. So sin x by tan x is also 1. So e power half into 1, that is half. E power half. Beta is e power half, that is root e. So if alpha and beta are the roots of the quadratic equation, I can form the quadratic equation. If you know the roots, we can form the quadratic equation. The quadratic equation is x square minus sum of the roots alpha plus beta into x plus alpha into beta is equal to 0. Alpha we got 1, beta we got root 3. So what do we get? X square minus 1 plus root e into x plus 1 into root e, that is root e equal to 0. I want to compare with this equation, ax square plus bx minus root e. Constant term is minus root e. So multiply by minus 1. If you multiply by minus 1, this becomes minus x square plus 1 plus root e into x minus root e equal to 0. Compare with this equation. What is the given equation? Ax square plus bx minus root e equal to 0. Correct? So minus root e, constant term is same. So if we compare the coefficient of x square, I get a equal to minus 1. I get a equal to minus 1. If we compare the coefficient of x, I get b is equal to 1 plus root e. Now I have to find 12 into log a plus b. Correct? 12 into log of a plus b. That is 12 into log of a is how much? Minus 1. B how much? 1 plus root e. Minus 1 plus 1 is going to cancel. So what you get is 12 into log of root e. That is 12 into log of root e is e power half. The half comes down, correct? Using property log m power n is n log m. The power is brought down. So 12 into what we get is half log e. Log e is 1, right? So answer is how much? That is 12 into half, that is equal to 6. 6 into 1, that is equal to 6. Correct? Log e is 1, 12 into half is 6, 6 into 1, 6. Required answer is 6. Numerical type question. So alpha is using limit of exponential function. Beta is 1 to the power infinity form. Then form the quadratic equation with roots as alpha and beta. Hence get the answer. Solution is also given to you. Answer is 6. More to the next one. Limit is there, integration is there. It's a combination of L'Hopital's rule and Newton-Leibniz. So many times asked. Same type of question. If I apply limit directly, x equal to pi by 2. Denominator see, pi by 2 minus pi by 2 0. Integral from x cube to pi by 2 cube. X is pi by 2 cube to pi by 2 cube. Lower limit is same as upper limit. So integral value is 0. So 0 by 0 form. Apply L'Hopital's rule. Differentiate numerator and denominator separately. Limit x tends to pi by 2 because it takes 0 by 0 form. Differentiate the numerator and denominator separately. D by dx. Integral from lower limit is x cube. Upper limit is pi by 2 the whole cube. What do you have? Sine of 2 into t power 1 by 3 plus cos of t power 1 by 3. Correct? Dt. I should differentiate that definite integral divided by d by dx of x minus pi by 2 the whole square. What do we get? Limit x tends to pi by 2. What do we get? Integration and differentiation is going to cancel out. Substitute the upper limit, differentiate the upper limit, minus substitute the lower limit, differentiate the lower limit. When you substitute the upper limit, it's a constant and derivative constant is 0. So upper limit you substitute and differentiate the upper limit is a constant, derivative constant is 0. Minus substitute the lower limit here, x cube we put, x cube power 1 by 3 is x, correct? What I get is sine 2x plus cos of, put t equal to x cube power 1 by 3 is x, correct? Substitute the lower limit, differentiate the lower limit, derivative of x cube is 3x square divided by, differentiate the denominator, 2 times x minus pi by 2 into derivative of x minus pi by 2 is 1. And still it is in 0 by 0 form. If you apply limit directly, 2 into pi by 2 is pi, sine pi 0, cos pi by 2 0, 0 plus 0 is 0, 0 into something is 0, denominator is pi by 2 minus pi by 2 0, 0 by 0 form. Again apply L'Hopital's rule, otherwise I can simplify one step. Sine 2x we know the formula, 2 sine x cos x. Sine 2x is 2 sine x cos x, so that I can take cos x common there, correct? So that is equal to limit x tends to pi by 2 minus 3 by 2 I'll keep outside. See, minus 3 by 2 is a constant here, correct? And here what is common? Cos x is common. Cos x is common means what remains is 2 sin x plus 1 divided by x minus pi by 2, correct? Into x square is there. This 3 is kept outside, 2 is also kept outside, minus 3 by 2. Now I can write cos x as sine of pi by 2 minus x using allied angles concept. Same type of question we had earlier also. Minus 3 by 2 is constant, keep it outside. Minus 3 by 2. Limit x tends to pi by 2 is there. What I can write is cos x as sine of pi by 2 minus x using concept of allied angles, divided by x minus pi by 2 is minus 1 into pi by 2 minus x, correct? Minus 1 into pi by 2 minus x, and 2 sin x plus 1 is there, 2 sin x plus 1 into 3 into x square. Now sine of an angle by same angle is 1, right? As x is approaching pi by 2 minus x is approaching 0, sine of an angle by same angle is 1. This minus into minus will become plus, 3 by 2 minus into minus plus, this is 1, and here x is becoming pi by 2, sine pi by 2 is 1, 1 into 2 is 2 plus 1, here x is becoming pi by 2, so pi by 2 square, correct? 2 plus 1 is 3, 3 into 3 9 pi square divided by 2 into 2 is 4. Hope I understand this. Sine of an angle by same angle is 1, x is approaching pi by 2, sine pi by 2 is 1, 1 into 2 is 2, 2 plus 1 3, so that is what I wrote. Here x is pi by 2 square, 2 plus 1 3, 3 into 3 is 9, 9 pi square by 2 into 2 4, 9 pi square by 4. Option, oh there's a mistake in the option I think, 9 pi square by 4 I'm getting. 9 pi square by 8. Oh, anything I did wrong? 2 into x minus pi by 2 minus 3 by 2. 2 square is 4. No, sorry, made a mistake here. Sorry, mistake is there here. Small mistake. 3 by 2 into 2 plus 1 is 3, correct? Pi square divided by 4. So what we get is 9 pi square divided by 8. 9 pi square by 8. Option B is answer. Pi by 2 square is pi square by 4. 2 plus 1 3. 3 into 3 9. 9 pi square by 8. Option B is answer. Question number 18 we have. Question asked on 9th of April, second shift 2024. Limit x tends to 0, e minus 1 plus 2x power 1 by 2x divided by x equal to how much? It's a different type of question. This is Quite unusual. So far not asked first time, but this type of question is found in R.D. Sharma book also. Okay. So you can practice such kind of questions. Limit x tends to 0 we have. If you apply limit directly, denominator is becoming 0, numerator is this e minus 1 to the power infinity, something quite unusual. We can't apply a proper method for this. We can't tell it takes 1 to the power infinity a L'Hopital's rule. What I'm going to do is, I'm writing this f of x power g of x. Variable power variable is there. F of x power g of x, I can write it as e power g of x into log f of x. I'm writing like this. F of x power g of x what? E power g of x into log f of x. I'm using this because exponential and log or inverse function will cancel out. F of x power g of x written as e power g of x into log f of x. So using that, e minus 1 plus 2x power 1 by 2x. I'm writing it as e power 1 by 2x into log of 1 plus 2x. Hope you understand. E power g of x into log f of x. G of x is 1 by 2x. F of x is 1 plus 2x. F of x power g of x is e power g of x into log f of x, using that, divided by x. Now this is equal to limit x tends to 0. Limit x tends to 0. E minus e power 1 by 2x into, using series expansion for log 1 plus 2x. Log 1 plus x is x minus x square by 2 plus x cube by 3, etc. up to infinity. Log 1 plus 2x will be 1. Not 1. Log 1 plus x is x minus, no, x minus x square by 2. X minus x square by 2, from there it is. So log 1 plus 2x will be 2x minus, log 1 plus 2x is 2x minus 2x the whole square divided by 2 plus 2x the whole cube divided by 3. Like this it goes on up to infinity. Log of 1 plus x is x minus x square by 2 plus x cube by 3, etc. Log 1 plus 2x is 2x minus 2x the whole square by 2 plus 2x the whole cube by 3, etc. up to infinity, divided by x. Correct? This is equal to limit x tends to 0. Limit x tends to 0, e minus e power, multiply this 1 by 2x inside. What do you get? This is 1 by 2x into 2x, that is 1, minus 2x the whole square. Here 2x will cancel, 1 2x will cancel, 1 2x remains, 2x by 2, that is x. Correct? 1 2x got cancelled, 1 2x remains, 2x by 2, that is x. Here 1 2x will cancel, 1 2x the whole square remains, 2x the whole square is 4x square, 4x square by 3. Like this it goes on. And e power 1 is common from this, correct? E power 1 is common. So what you get is limit x tends to 0, e power 1 is common. So what remains is 1 minus e power of minus x plus 4x square by 3, etc. up to infinity, divided by x. E power x series expansion you can apply. What is e power x series expansion? 1 plus x square by 2, etc. up to infinity, x square by 2 factorial. But not all the terms required. Denominator is x, no, only up till x is enough for me. X square also not required, because all those terms will become 0, because we know limit x tends to 0 is there. Limit x tends to 0, e into 1 minus, writing series expansion for e power x is 1 plus x square by 2. What is series expansion? 1 plus x, my x is this entire infinite series, correct? This entire thing is x. Series expansion I am writing for e power x, where that infinite series itself is x. So 1 plus x is minus x plus 4x square by 3, etc. up to infinity. That is my first term. This is my x. Plus x square by 2 factor, all those things not required. All those terms will become 0. Okay, I'm not writing those terms. Divided by x. Here 1 minus 1, 0. Minus of minus will become plus. E you can keep outside. E is kept outside. Limit x tends to 0. Correct? Now what is there? 1 minus 1, 0. Here minus into minus will become plus x. Correct? Plus x. And minus into plus become minus. 4x square by 3, correct, etc. up to infinity divided by x. And you separate the terms, x by x is 1. Rest all terms now from here it contains x. This will not contain x, it becomes constant. X by x is 1 and 4x square by 3 by x becomes 4x by 3. 4x by 3 is becoming 0 because x is approaching 0. So what we get is e into 1 minus rest all terms from here onwards, everything will become 0 because it will contain x and x is approaching 0, so it becomes 0. So e into 1 minus 0, answer is e, over. So different type of question asked for the first time in 2024. So far it was not asked this type of question where we use this kind of f of x for g of x, so e power g of x into log f of x. But these kind of questions are there in R.D. Sharma book, I have seen it. Okay, please make a note of this. Using this formula and writing expansion, series expansion for log 1 plus 2x. Log 1 plus x is x minus x square by 2 plus x cube by 3, etc. Log 1 plus 2x is 2x minus 2x the whole square by 2 plus 2x the whole cube by 3, etc. Then multiply this 1 by 2x inside and you can take e power 1 common. E is there, e power 1 is common, and e power what is left is 1 minus e to the power minus x plus 4x square, etc. E power you can write the series expansion, e power x series expansion. This entire infinite series is my x. So I am writing only the first term here, 1 plus x, x square by 2 factorial, etc. not written because all those terms will become 0. When you separate, divide by x and apply limit, it becomes 0. Hence answer is E, option C is the answer. Solution is also given to, detailed solution is given to you. And correct, no? Last question we have, 19th one. Limit n tends to infinity, 1 square minus 1 into n minus 1 plus 2 square minus 2 into n minus 2 plus and so on, n minus 1 the whole square minus n minus 1 divided by summation of n cube minus summation of n square is given. Want to find. Question asked on 6th of April, second shift, 2024. Here you have to use the concept of series here. This is sigma n cube, this is sigma n square, and limit n tends to infinity is there. If degree of numerator and denominator is same, it is limiting values nothing but the ratio of the leading coefficient. That also we know. Correct? Look at the numerator. I'll generalize this. Limit n tends to infinity. Limit n tends to infinity. The first term is 1 square minus 1 into n minus 1. Second term is 2 square minus 2 into n minus 2. Last term is n minus 1 the whole square minus n minus 1. Into 1 I can write. Into 1. That into 1 is n minus 1. See, second bracket of the first term is n minus 1. Second bracket of second term is n minus 2. This is n minus 1 bracket. Correct? 1 square minus 1, 2 square minus 2, n minus 1 the whole square minus n minus 1. That means it is n minus 1th bracket. That means there are n minus 1 terms altogether in the numerator. And into 1 if we consider here, that 1 is n minus of n minus 1. Correct? N minus of n minus 1 is 1. See, first term, second bracket is n minus 1. Second term, second bracket is n minus 2. And n minus 1th bracket, n minus 1th term is n minus 1. Second factor of the second bracket of n minus 1th term is 1. 1 is n minus 1. Correct? This one is n minus 1. This one is what? N minus of n minus 1. Correct? So I can generalize how many terms are there in the numerator. There are n minus 1 terms. I'll write in terms of summation. Summation r is equal to 1 to n minus 1 because there are n minus 1 terms. The first bracket I can generalize it as r square minus r into second bracket is n minus r. Correct? If you apply summation r is equal to 1 to n minus 1, we get sum of all the n minus 1 terms. First term is got by putting r is equal to 1. Second term is got by putting r is equal to n minus 1. The term is got by putting r equal to n minus 1. Correct? And denominator is summation of r is equal to 1 to n of r cube minus summation r is equal to 1 to n of r square. correct? Multiply numerator and apply summation formula. Limit n tends to infinity, limit n tends to infinity, what we have? Summation of r is equal to 1 to n minus 1 r square into n, correct? Here it is r square n minus rn, r into n is rn, minus r square into r minus r cube, minus into minus plus r into r is r square, divided by summation of r is equal to 1 to n, that is r cube, minus summation of r is equal to 1 to n, this is r square, correct? And we know the formulas for these two. Apply summation for all the terms here. Using the property of summation, I can apply it. So limit n tends to infinity is there. Limit n tends to infinity. What we have? R square. Summation of r square is what? There are n minus 1 terms. N is a constant here. Summation of r square, where r is varying from 1 to n minus 1. Summation of n square is n into n plus 1, 2n plus 1 by 6. Summation of r square, if it is n minus 1 terms, it will be n is constant to keep as it is. And summation of r square is n into n minus 1 into 2n minus 1 divided by 6. Minus Rn, summation of r into n. N is constant, summation of r for n minus 1 terms is n into n minus 1 by 2. This is minus n into what we have, that is n into n minus 1 by 2. N into n minus 1 divided by 2. Minus summation of r cube for n minus 1 terms will be n square into n minus 1 the whole square divided by 4. And summation of r square for n minus 1 terms, that will be how much? That will be n into n minus 1 to n minus 1 by 6. Okay, there is no space here, I'll write here itself, don't mind, plus n into n minus 1 to n minus 1 divided by 6. This is numerator part, okay? This is numerator part, divided by denominator is here. Denominator is summation of r cube for n terms will be n square into n plus 1 the whole square divided by 4, minus summation of r square for n terms will be what? N into n plus 1 into 2n plus 1 divided by 6. Like this. This entire thing is numerator, this is denominator. And you see the highest power of n in the numerator is 4. Here n power 4 I'll get. Here it is n cube. Here also n square into n square, n power 4 I get. Here I get n cube. So denominator is here also I get, if I expand n plus 1 the whole square I get n square. N square and n square is n power 4. Here I'll get n cube. So when limit n tends to infinity is there, numerator and denominator both are polynomial and they have same degree. Limit n tends to infinity, if you take the limiting value of that, if n tends to infinity is given, limiting value is nothing but the ratio of the leading coefficient. That means coefficient of highest power of n in the numerator by coefficient of highest power of n in the denominator, correct? Limit n tends to infinity is there. Already we did this kind of questions earlier also. In the synopsis also I explained in detail. Okay. So here you see coefficient of n power 4 is how much? Here n I get. 2n power 4 I get. Correct. Coefficient of n power 4 is 2. 2 by 6. As n tends to infinity, 2 by 6. And where n power 4 is there, only such coefficients I am taking, because the power of n 4, that is highest power of n is 4 here, correct, in the numerator. Here I get n cube, that doesn't matter for us. Here I will get n square and n square, n power 4. Coefficient of n power 4 is 1 by 4 there, correct. Here I get n power 4, here I get n power 4. These two I won't get, that's n cube, that is not important for us. And here n square and n square is n power 4. Its coefficient is 1 by 4. And this is n cube, that is not required for me. 2 by 6 is how much? 1 by 3. 1 by 3 minus 1 by 4 divided by 1 by 4. Correct? 1 by 3 by 1 by 4. Separate the terms. What is 1 by 3 by 1 by 4? That is 4 by 3. Correct? 1 by 4 by 1 by 4 is 1. 4 by 3 minus 1 is 1 by 3. Answer is 1 by 3. Answer is 1 by 3. That's what we got. Detailed solution is given to you. When degree of numerator is equal to degree of denominator, n tends to infinity is given. Limiting value is ratio of the leading coefficient. Means the coefficient of highest power of n in the numerator divided by coefficient of highest power of n in the denominator. Both numerator and denominator should be polynomial of same degree. Then only it's applicable, and limit n tends to infinity should be there. And also given the examples also for this type of. So we're done with limits of 2024. January shift and April shift I have covered. Okay, all the problems were covered. 19 questions were there altogether. Correct? 19 questions were there. Answer is 1 by 3 we got. Option B is the answer. Detailed solution is given to you. Please subscribe to my channel, Abhiram's Maths Marathon. I'll be uploading many more videos. I'm a YouTube beginner still. In the beginning itself we started with KCT 2025 we started just a month ago. Okay, I'll be uploading many more videos connected to JEE exam. Not only JEE exam, BITSAT, MAE, and even IISER, NDA, various competitive exams, VIT, EEE, all PYQs will do one by one. Okay, chapter wise we shall work out, and synopsis will become very strong because synopsis plays a vital role in competitive exams, in solving the problems for competitive exams. Synopsis should be very strong. Without knowing the formulas and equations, it's of no use. Please write and study all the formulas, particularly the trigonometric formulas, differentiation formulas, integration formulas are very important. And this is the right time. If you are in 12th standard, this is the right time to start studying for JEE exams. Start preparing from today itself. We're done with synopsis of limits, and 2019, 2020, 2021, 2022, 2023, 2024, all PYQs of JEE exams are solved completely, and it's uploaded in my YouTube channel, Abhiram's Maths Marathon. And also the solutions in the PDF format will be sent to you, and question by question video solution is also available. Okay, 2025 I'll do it in the next class, in the next session. Okay, with this we'll conclude. Thank you for watching. Thank you.